Okay, and we start. Welcome everyone. Thank you for joining this talk. I think here is better. So, okay, to get started, my name is Julian Len. I'm from Argentina. I've been working with Patricio on the project I'm going to present today. I'm a research engineer in Rootstock Labs. Right now, I'm the research and tech strategy team. So let's get started. Okay, so why we did this project? So as you know, today when a user sends a transaction, he needs to expect, at least in Rootstock, 30 seconds to know that his transaction is already in the chain. Okay, so this time is good if we compare it with Bitcoin, that takes like 10 minutes. But we can make it better if we compare it with the traditional payment processors or another chains that they are like almost instantaneous. So, okay, and that's why we came up with Faster. It's a new protocol to, as I said, reduce the transaction confirmation. Okay, at first, let's introduce Rootstock. Rootstock is a Bitcoin sidechain, a merge-mined Bitcoin sidechain, which mainnet was been up since 2018. And we use Bitcoin as our currency. We trust in Bitcoin, so we don't have our own cryptocurrency. We use Bitcoin. And the difference is that when the Bitcoin is on our chain, to differentiate with the Bitcoin in the Bitcoin network, we call it Smart Bitcoin. Also, we have the RVM, the Rootstock virtual machine. This is an EVM-compatible virtual machine that allows us to bring all the DeFi world and the NFT world into Bitcoin. Okay, so regarding the consensus in Rootstock, these are three key players that are part of our consensus. The first one is Nakamoto consensus, well-known, Ghost, and Decor+. So, for the Nakamoto consensus, we have the proof of work consensus protocol that everybody knows, of course. And regarding the rules to break the tie when there are two forks competing to be the main chain, in the Nakamoto consensus, they used longest chain. It means that the chain with more blocks will be the main chain. But it changed with Ghost, because with Ghost, that it's a newer consensus protocol, it adds the rule that the chain who is gonna be the main chain considers the ankles or the stale blocks, the blocks that are not part of the main chain. And Decor+, the current consensus protocol in Rootstock, adds some features that make this four-choice rule, this consensus protocol, more efficient without implying more execution time. Okay, so which are the contact points with Bitcoin? I say that we are a sidechain of Bitcoins. So the first one is the PoW. The PoW is a two-way mechanism that permits to transfer the Bitcoins to the Rootstock network and vice versa, to convert the smart Bitcoin to Bitcoin. This is possible thanks to two key features, the bridge and the federation. That the federation doesn't have much control in what they sign. Actually, they don't have control. So it's a really decentralized bridge. And another key player is the merge mining. Okay, so let's talk about merge mining more in depth. So merge mining is a mechanism that leverages the Bitcoin mining hashing power to use it also in different chains without implying more work for those miners. And of course, that brings to those miners more rewards. So it's a really good property. So why we can use that in Rootstock? So Rootstock has the same mining algorithm than in Bitcoin. Basically, we hash block headers, and we try that the hash resultant should be lower than a target. If the hash is lower than a target, so the proof of work is valid. Another property is that the lower the difficulty, the easier to find a correct hash. And of course, if we will have different hashing function, this is going to be impossible. So yeah, we share the same hashing function, that is SHA-256. So this makes possible to merge mine Rootstock with Bitcoin. Okay, some more properties. The first one, finding a valid proof of work in Bitcoin is way easier than in Rootstock is way easier than in Bitcoin. This translates to the block production rate. While in Bitcoin is 10 minutes, in Rootstock is 30 seconds. And of course, all solutions, proof-of-work solutions in Bitcoin, are always valid in Rootstock. And this is the mechanism. So what the miner does is they include in the Bitcoin block the last Rootstock. They build the Rootstock block, and they include it in the Bitcoin block they are going to mine. So they hash that, they apply the proof-of-work function, and here there are three possibilities. The first one, they find a hash that is lower than the target in Rootstock. So what they do is they include the Bitcoin block inside the Rootstock block, and they send the Rootstock block to the Rootstock network. The second option is that it's valid for Bitcoin, the hash, so they will earn the rewards. Something that I forgot to mention, when they mine for Rootstock, they are earning more rewards in Rootstock. So if the solution is valid for Bitcoin, they can send that block to Bitcoin and also to Rootstock, because I said the solutions valid for Bitcoin are always valid from Rootstock. And finally, if it's not valid for any chain, they will keep iterating hashes. Nowadays, the Bitcoin hash rate that is in Rootstock is almost the 50%, so that makes Rootstock a really secure chain. It is really secure by the Bitcoin network. Okay. So we are getting closer to the merge mining bottlenecks, but at first we need to understand how it works in reality. So the miners, there exists solo mining, but most of them join together to join the hashing powers in what is called a mining pool. And the mining pool looks like this. There is a pool server that sends the last block to the miners that we call workers inside or through a mining pool network. The miners will start hashing those blocks and will send each hash to the pool server that will check if it's valid for one of the networks. So yeah, at first the pool server builds the block, sends to the workers, they mine, and sends the hashes to the pool server that checks if it's valid for Bitcoin or Rootstock. If after 30 seconds the non-worker finds a valid solution for Rootstock, they will check if there is a better block in Rootstock, and they will refresh the Bitcoin template with the newer Rootstock block. But why every 30 seconds? So this number is not arbitrary. This number, we find that if we ask the miners to refresh their template every less than 30 seconds, they can lose some of the rewards from the Bitcoin mining. And this also makes that we can get transaction confirmation in less than 30 seconds. So this is a limitation. So how can we get around this? The first solution asks the miners to reduce the Bitcoin template, even though they can lose some of the Bitcoin rewards, and to reduce the block difficulty so they can find blocks faster than 30 seconds, and they can confirm transactions in less than 30 seconds. And the second solution is faster. Faster stands for fast and secure transaction epoch-based resolution, and is the protocol we've been working in the research team the last year. And this is the juicy part of the talk. OK, so what we did is to include proof-of-stake blocks within or in between the proof-of-work blocks that we have right now. This post block allows us to reduce the confirmation of the transactions in 5 seconds. We have more flexibility with the proof-of-stake blocks. So for the proof-of-stake part, we are really based on LMD Ghost, that is the four-choice rule that is used in Ethereum. And as a first rule, and in this first version, we will allow just the miners to stake. So they will be stakers and PoW miners. And by staking, they become part of a committee, that is the group of validators. The role of the validator is to, as I said, validate the post blocks, and if valid, vote on them. So let's see how this works. OK, so every time a PoW block shows up, among the committee, one validator is selected as the leader, and an epoch starts. This leader is the one who proposes the post blocks every 5 seconds. We call those post blocks microblocks. Unlike what is now in Rootstock, the PoW blocks won't contain transactions, but the microblocks will. So the leader proposes a microblock, the committee will execute the transaction, and if it's valid, will vote on what they consider the best block. Okay. In the next lot, what the leader will do is to include those votes in the new proposed microblocks. And that's how the chain in between the PoW blocks will work. But what we do with the PoW blocks? So we say that there is a supermajority when a block receives more than 2/3 of the validator votes. And we also say that the microblock is confirmed when it receives those votes. So the PoW block will include the last confirmed microblock into it, and we'll start mining with the last microblock confirmed. So we are adding proof of work into the microblock chain. And that's why we call it will work like a checkpoint. So that's why we call these blocks checkpoint blocks. And this is how it looks at the end. So we have the checkpoint block with the hash of the last confirmed microblock. Okay? And it will start a new epoch, and this round starts over again with a new leader and a new committee. OK, so we are reaching the end of the talk. Let's say some conclusions. At first, we got to reduce the transaction confirmation time doing this to 5 seconds. Of course, it's not perfect. This protocol adds a lot of complexity to what we have in Rootstock. Right now, merge mining is pretty straightforward and simple, and by adding this, we are adding some more complexity, but it has a lot of benefits. For instance, well, having transaction confirmed in less than 30 seconds, in 5 seconds. And if we have more than 2/3 of validator honest, we can guarantee a partial finality of the transactions. And merge mining remains unmodified. If a miner doesn't want to stake, he can still merge mine the PoW blocks and earn some rewards. And of course, proof of work keeps giving the last finality and the stronger finality to the protocol. And some ending words. Of course, this is open to everyone to collaborate, to give feedback. If you want to, there is this link tree. If you want to be part of, or if you have any suggestion, or in the research forum, we will be sharing all the documents to collaborate. And that's it. Keep building on Bitcoin. Any question, any comment?
What's the impact on the tokenomics?
Yeah, well, we are working on the part of the incentives and rewards, but like in this first version, we say that by having more transactions, we will have more rewards to split into the miners. So more or less, it remains the same as it is right now. So, but with more fees.
Part of the proof of work reward to the proof of stake, right?
Yeah.
How do you choose the next validator?
No, so far, it's like the committee is always the same, and there is a random function that selects a leader from the committee.
It's random.
Yeah. Yeah, it's pretty similar to what it has Ethereum right now. They use Randao. Our mechanism is simpler so far, but the idea is like using the proof of work hash as a seed for the random function.
How are you thinking about slashing validators?
Well, yeah, we thought about that. There is, like, so far there are 2 equivocations, like voting in the same slot for many microblocks. That's for the validators. And for the leader, if he proposes 2 microblocks with in the slot or in different slot with the same parent, it is slashed also. The idea is to, once the validator or the leader is slashed, it has to wait for some epochs until he can stake again and be part of the committee.
And then, like, if you want, how large do you think the committee size is?
Well, right now I think it's gonna be like 10 miners, more or less. But yeah, so for this version, we are not opening to everyone to have a more controllable environment. And we will test if this works. And our idea in the future is maybe to open it to everyone, the staking.
So the idea is not to be more decentralized than proof of work, but to be faster blocks.
Yeah, yeah. And you?
One more question.
Yeah, of course.
Sorry, if the committee's fixed and it has 10 validators, if the committee doesn't include a specific transaction into the microblocks, can a user bypass the committee, or are they always relying on committee members?
No, they rely on committee members. Yeah.
For every group, you need 2 over 3 voters, right?
I mean, to a microlog to be confirmed, we expect more than 2/3 of micrologs. But yeah, if we don't reach that number, that means that it's going to be impossible to have confirmed micrologs, so maybe we need to, again, fall back to merge mining, to plain merge mining.
I remember we discussed when we were in our section to use the proof of work blocks to force include transactions that would be queued on the blocks to prevent
Yeah, okay.
hackers being excluded from being censored. Are you still considering that, like proof of work blocks having a
Transactions. Well, probably for the, yeah, I mean, for this version, no, but I mean, to implement this, we will need to see if the transactions to the bridge transactions, maybe they need to be included in the proof of work blocks and not in the proof of stake blocks. Yeah, there are some, yeah.
I see there's a kind of very tricky part because proof of work favors liveness over safety, and proof of stake favors safety over liveness. If you combine them together, probably there will be like some points that you have to kind of trade off. You have to favor proof of work or
Yeah, I mean, we favor proof of work. At the end, who controls the network is proof of work. But as it works, they are always confirming because the proof of work includes the last confirm, but the leaders, the seed of the proof of work that chooses the leader is from a really old epoch. So if there is a reorg, it is already solved. I don't know if I've been clear. Okay, so that's it.
Thank you very much. I hope that this microphone works. We don't need acoustics or speakers for this room, but I hope that the people listening on live stream are able to hear this. And last year when I was in Argentina to attend La BitConf, I met Sergio, and he was obsessed with BitVM. It was his latest discovery, and he was always talking about it. And I knew at the time that it was only a matter of time until he comes up with some sort of workaround to improve its limitations. And it wasn't long after that I heard about BitVMX, which is a creation by Rootstock. And right now we're going to get Ramon, who's going to speak about BitVMX and conflict resolution and how that can happen within this very interesting and exciting virtual machine built around Bitcoin. So here's a short round of applause for Ramon and BitVMX. And for the people listening on stream, this is a great opportunity for you to learn about what's coming to Bitcoin, because it seems like Ethereum was just the test net. Yeah, there's a camera there. We're live. So whenever we're ready. By the way, this radiator, if it's on camera, it looks just like the PlayStation 5. So this is like the prototype for the PlayStation 6 that we have right here. And while you're on the live stream, make sure you follow Rootstock and Rootstock Labs to check out their work. It's all very interesting. Go to rootstock.com and you're going to find information about their software. It's a Bitcoin sidechain, which is always evolving. Are we set for the PowerPoint presentation?
Yeah, almost there.
Okay, Ramon, the stage is yours.
Thank you very much. Yeah, let's start at the beginning. So good morning, everybody. My name is Ramon Amela, and I'm researcher at Rootstock Labs, as he has been just nicely presenting me. And I will be explaining how BitVMX works in a simple way and giving some hands-on examples. So this will be a little bit the outline of the talk. I will be explaining a little bit about the Bitcoin context, then do a recap of some nice concepts that are applied in BitVMX to pass afterwards to show how the N-ary research on-chain works and how we perform the error resolution on-chain. Finally, we'll do a hands-on when we will show these two concepts in real examples in mainnet, testnet, and Mutinynet. So, the Bitcoin context. As you may know, if you have ever coded in Bitcoin, Bitcoin is not like Ethereum or other blockchains that have smart contracts and are really expressive. In Bitcoin, we have stateless scripts, so we don't have the concept of database or state or the capacity to pass variables from one transaction to the other. We have very limited amount of opcodes, meaning that we are not even able to multiply or concatenate or do meaningful things, so we are extremely limited. There's no transaction introspection, so we cannot say where the money from one transaction will go or limit where the money comes from. So we just have some conditions to spend a UTXO, and then we don't know anything from the transaction inside the script that will free these funds. Finally, we have signed arithmetic operations with at most 32 bits. That it's 4 bytes. That is super small. Taking all this into account, some people have done some research to kind of stretch a little bit the script and try to overcome all these limitations. So I'm talking about the connectors, the Winternitz one-time signatures, and the chain hashes. At first, I will explain all these concepts because they are really important on the continuation. So what is a connector? As you may know, Bitcoin is a UTXO-based blockchain. So basically, we have a transaction and a block. And in this block, we put transactions. And these transactions have several outputs. So we can identify an output by the transaction ID and the index of the output. If we want to spend this output, we need to give to the blockchain the conditions that fulfill the destination address, and then specify where do we want to send these funds. So if we build, when we build a transaction, we say as we said, where the funds are coming from, expecting that this origin transaction has been published. In addition, there are several ways to free the funds. We have pay to public key, play to hash, SegWit, or Taproot. And in this case, we choose to use Taproot. Why? Because it has two nice properties. One shared with SegWit, that is the witness will not affect the transaction ID, meaning that we can build a transaction without knowing the input that we will give to it afterwards. So we can build a chain of transactions without knowing the actual input that will be given to these transactions. And the second one, Taproot, is that we can encode a huge amount of scripts in a transaction without knowing which one of the scripts will be used afterwards to free the funds. So, for example, we can define that the transaction B will use one of 10 scripts without knowing which one will be in the future at the time of signing the transaction. Once we know this, we can build a chain knowing that the transaction B cannot be published until transaction A has been published, and transaction C cannot be published until transaction B has been published. This allows us to create a huge chain of transactions without the need of publishing them. So we can, let's say, we can block the funds in the transaction A, and then wait an arbitrary amount of time until a counterparty publishes B, even though I already have the transaction C in my power, let's say. And then when another party publishes B, I publish C, and we keep publishing this chain. It's really important to think that we can generate the transactions without actually publishing them. And since these transactions can be signed by an arbitrary amount of people, if these people burn the private key they have used to sign these transactions can no longer be modified, so this becomes a trustless chain. That is not really trustless because we are trusting on the parties burning this private key. Until now, we were talking about a chain that is linear. So basically, we had the transaction A that goes to B and B that goes to C, but we can think in a schema like this one. We can think on two transactions that are input of a new transaction. So when we build this, we say that we cannot publish C until A and B have been published, creating a dependency. This will allow us to, for example, lock the funds in one transaction, that would be transaction C, and then in order to spend these funds, we need the two inputs A and B. And the B could be, for example, the result of BitVMX. Knowing that we have the funds in A, we execute BitVMX in B, and in order to take the funds, you need to win the game in BitVMX. This allows you to create a schema in which the resolution mechanism and the funds are not together. So BitVMX has no real funds on it, and if you win, you can take the funds from anywhere else, from somewhere else, sorry. And then we have this other mechanism. We can think on two transactions that have the same input. So beforehand, we sign these two transactions, and you know that since Bitcoin forbids the double spending, UTXO can only be used once. So if you have transaction B and transaction C, you know that once this transaction A has been published, you'll be able to either publish transaction B or transaction C, which means that de facto what you're doing is you are opening a graph where once transaction A has been published, you choose to follow either the path B or the path C. Once you choose to follow one of the two paths, the other path gets burned. So this is a little representation of what I was explaining, saying that you cannot follow the two paths, you need to choose one of them. So as summary, these connector things allow us to create a directed acyclic graph with dependencies, saying that all the inputs of one transaction need to be published in order to publish another transaction, and mutually exclusive paths. So points where the actor that's publishing these transactions need to choose the path that wants to continue. Keep in mind that here I'm just putting those two outputs, for example, in the mutually exclusive paths, but we could have an arbitrary amount of outputs. The next thing that I want to present is the Winternitz one-time signatures. This is kind of an invention to work around the fact that we don't have a state in Bitcoin. So in all these connectors that we have seen before, we don't have the capacity to pass variables from one script to the other, since Bitcoin has not state. But what we can do is use a little trick and put in the script a public key that encodes a variable, and say that, OK, the actor that will publish this script will have to give a certain value for this public key. And we can say that the only value that he will be able to publish there is one that has been published before. With this schema, we can kind of pass state from one script to the following one, since, yeah, sorry?
In BitVM, Robin is using Lamport signatures, I think, for the same thing. What is the difference between Lamport signatures and Winternitz signatures, and why did you choose to use Winternitz signatures?
Yeah, so they started using Lamport signatures, and now I'm not 100% sure what they are using, because in all the presentation they keep saying that they are using Lamport signatures, but if you look at the repository, they have coded the Winternitz signature. And the point is that, OK, I'll start explaining what Lamport signatures are. I will change this and explain before Lamport, because you are right, it's the kind of the logical initial explanation. So basically, Lamport signatures, you encode a 0 or a 1 with a public key, and you follow the same schema. So basically, you have a seed, so you generate a private key, and then you hash it with an arbitrary hash function. This hashed value will be your public key. So you'll put in the script this public key. Only the owner of the private key, in fact, can give a value that once is hashed, give you this public key. So basically, you'll put the last value in the script, and you will say, OK, give me a value that once is hashed gives this value here. Only the one having the pre-image can publish this. So either you have the pre-image from the beginning, either the counterparty has published the pre-image in another transaction, you go to this transaction, take the value, and put it in your script. So basically, Lamport allows you to just code the 0 or the 1, because you are just hashing one time. Let's say that each public key is encoding just one value, right? But now we can imagine that instead of hashing once, we hash twice, or 3 times, or 4 times. And what you are publishing when you are putting in the script is this last value. And you say, OK, if I give you this, you will hash one time to obtain the last value. That means that this value is the equivalent of the 0, because you have hashed the value plus one time. If I give you this will encode the 1. If I give you this will encode the 2. If I give you this will encode the 3. So with just one public key, instead of encoding just one value, we are able of encoding more than one value. And this has a really nice property that these keys are pretty large. And it may not seem important, but you'll see afterwards in the hands-on, this transaction start being hyper huge. This is, well, I make a spoiler. Since we are in Bitcoin script, this arbitrary hash function SHA-256, but then you think, OK, the SHA-256 is 32 bytes, and the space is really important, so we call the hash 160 that will do the ripmd 160 that will give us a shorter. We do just this to have a shorter key. So if we look at it, I change a little bit the wording. So we don't have hash values and the seed. Suddenly, what we have is the private keys and the public key. So if you want, keep in mind that we have this the value 0, the 1, the 2, and the 3. So basically, if you want to, for this variable encoded in this public key, you want to say, OK, I will set this variable to the value 2. You will publish this private key. But this has a problem. And the problem is that, OK, if you publish the number 2, it's impossible that I know the number 3, because only you that have the seed private key knows this value. But since we are chaining the hashes, if I publish the number 2, everybody that's looking in the blockchain can compute directly the number 1, the number 0, and the number 0, because the only thing that needs to be done is keep hashing. Then, if I publish this value in one script, and I expect this value to be the same one in the following script that another party will publish, I cannot trust this mechanism anymore unless I put a checksum. So how the checksum works? Let's say that we have two values, because at the end, what we will be doing is encode big hashes. So we'll chunk the hash in parts, and each one of the public keys will encode a certain part of the hash. So we'll have a lot of public keys to encode the whole hash. Let's say that we have these two values, and we publish these two zeros. These two values remain private. So nobody can give neither this value or this value looking at the blockchain. So the checksum will show these two values. So we'll publish this. All the values in the checksum are visible in the blockchain, but only these two values are visible in the blockchain. And the mechanism is like, if we show one more value of this side, we'll show one less value on the other side. So if now we choose this value here, we can compute this just by hashing, but we'll show this one. So this one remains hidden. Again, if in this side we show one more value, we'll show one less value here. So if you keep counting as you do all the combinations, in this schema here, we are encoding, here we have 4 values. Here we have 3 values, and there are always 2 hidden values. In this case, there are these 2. We pass one hidden value to the right, another hidden value to the right. If you can keep doing all the combination, you cannot change this value, because then you cannot give a valid checksum, because the hidden values are in the checksum. If you show one more value in the checksum, you will be hiding values in this side. So what you achieved with this mechanism is you found a way of ensuring that once you give a signature, the counterparty cannot change it. You are forced to publish exactly the same thing that has been published, because you don't have the means to change it, because you don't know the seed. So since there are hidden values that you don't know, you don't have the capacity to change it. And if you change one thing that you can change, normally you should show one thing here that you don't know. And with this, we are able to kind of give a state on Bitcoin. Because a party, a party can publish one value, we encode this same value with the same public keys in another transaction, and the counterparty publishing this transaction will be forced to publish the same exact value that has been published before. The counterparty will not be able to change the value, but what if this value needs to be presented again from the party that published it the first time? Since this party knows all the private keys, could be able, technically, to change the value. So to work around this, we have two possible solutions to avoid it. That is, include a certain path to penalize it. And this is called Equivocation. And people, what does is like, in all the chain that I presented before, they put an exit path in such a way that if one party can give two values for the same public key, all the funds are slashed. And normally, if I'm a party that don't have the private keys, the only way that I have to publish two different values is if the counterparty lied at some point. So they published one value in one script, and for the same public keys, they published a different value. So now I have two different values for the same variable. I'm able to slash the funds. Nevertheless, we chose another path, that is, if one counterparty published a value, so let's say in the variable a, one party published a 3, we can reassign this value in a later script in such a way that I present the same value that I had here, and I sign it with one of my keys. So now we have the same value signed with the keys of the two parties, in such a way that the one party will always use the public keys of the counterparty. Since, let's say, actor A and B. A has published the value 3 on the blockchain and has signed it. The actor B presents the same value and signs it with its keys. From that point ongoing, if B needs to use this value, we'll use the public key of A. If A needs to use this value, we'll use the public keys of B. Since you don't have the private keys of the counterparty, you have no means on changing the value. And the last recap concept that are the hashed arrays. And basically, this consists on taking an array of values and keep hashing them one after the other. So if we imagine that we are in an arbitrary step n, what we would do is take the hash of the step n minus 1, take the value n, so let's say the value 3, to put an example, concatenate the previous hash and the current value, and hash this. If we consider that we can only know a hash if we know the pre-image, if we both agree on the value of a certain hash, we can get to the conclusion that we both had the same hash in the previous step and the same value in this position of the array. Keeping that in mind, I repeat this because it's pretty important, agreeing that if we have the same hash for a given step, we know that we had the same hash in the previous step and the same content in this position. And by induction, we can say that we have the same content in all the previous content in this array. And we consider that in this array, we can put transactions, so we can have an array of transactions. We hash all of them one after the other. And if we share the same hash at the end, we can say that the array contains all the same transactions. We can put computation steps or anything that can be vectorized and hashed. Keeping that in mind, what we can do is we take an array of values and we transform this array of values on an array of hashes. And with this array of hashes, we can, if we are not sure of having the same values equal, what we can do is we publish the last hash, And we both look, I publish my hash, and the counterparty will look at this hash. If both hashes are equal, we can say that all the values in the array were equal, right? Just from the property of the thing that we saw before. In case of disagreement, we know, OK, at the beginning, we have the same thing, that's an empty array. And at the end, we have something that's different. So let's find where we diverged. And then you start publishing the intermediate states, saying, for example, in a binary search, you can publish the value that's in the middle. If this hash is equal, we can say that the divergence is in the second part. If it's different, we know that the divergence is in the first part, in such a way that you can start doing a search in such a way that you will end up in one hash that is equal for the two parties, one hash that is different, and then you know that the divergence is in this exact step. We can show this in a graphical way. Let's say that we have 15 steps. This, we could publish the 15 and then do a search in such a way that I say, OK, if you show me 3 values, I'm splitting the space in 4 different intervals. And when you choose one of the intervals, I will show you the values that come afterwards. How we define these intervals is important because if we choose certain lengths, what we'll be doing is, as long as we are choosing one interval or the other, what we'll be doing is choosing the exact step that is different. So imagine now, let's put it as an example, that the step that is different is the number 6. What we'll be doing is, first, we'll publish the 15. The counterparty will say, OK, the one that's different is the 7. We'll publish the 3 that come afterwards, and then we'll choose the 10 in this order like this. And following the property that I showed you before, if you concatenate 0, 1, 1, 0, in fact, in binary, the number 1, 1, 0 is the number 6. So just by concatenating the choices, you obtain the exact step that is different. And going already for the last part of the presentation, now let's imagine that you build an emulator of, for example, RISC-V. You execute a compiled program, and at each one of the steps, you are able to extract this information of each one of the instructions. In such case, you can take all this information, hash it together, get to the end, compare if the 2 hashes are equal, and if 2 hashes are equal, you can say that an arbitrary execution was exactly the same in 2 counterparties that executed this in 2 different computers and without any connection between them. In fact, if we consider that we start the execution with an empty machine, you don't need to hash all the read values because at each time, the only thing that's modifying the state of the machine are the outputs, that are the ones that are modifying the state of the memory. So what you can do is just keep hashing the output values as long as the execution keeps going. So I recap and I come back to this previous slide where we had these values and we transform the values array to the hashed array. So now what you can do is have this execution, you put all the output values in the values array, you generate the hashed array, and with this hashed array, you can perform an N-ary search to find which is the exact step that gives you a different hash. And once you know which is the step, you can ask to the party you can ask to one of the parties to say, OK, now we have a hash that is correct and a hash that is incorrect. show the content of the middle. And once the content in the middle is being shown, that is basically all these values here, you have different sources of discrepancy. The first one, the hash computation challenge. So if one counterparty shows the content in the middle and the previous hash was equal, we have exactly the same values here, but the hash is different. What is wrong is the hash. What you can do is, on-chain, you compute the hash, and you demonstrate that the hash computation was not correct. And then you slice the funds. Imagine that you compute the hash, but the hash is correct. What is incorrect are the outputs. So what you'll need to do here is execute this RISC-V command on chain. You don't need to run the whole computation of the 4 billion steps. You only need to run one single instruction to demonstrate the disagreement. And then, if you execute this on chain and you prove that the outputs that have been given by one of the parties are incorrect, just by executing this on chain, you can prove that the execution was incorrect. And we'll call this challenge execution challenge. Then, remember that we had this hash that was correct, this hash that was incorrect. Let's say that you look at the information that has been published, and what is different is the program counter. Considering that the program counter is being written here, you can ask the counterparty, OK, give me the previous hash and the outputs that give this hash. Since this hash was the same for the two of us, the previous program counter should be exactly the same, since you need to know the pre-image. So basically, the counterparty will not be able to give you a previous hash and a program counter that hashed give the correct hash, being the program counter different from what you have. So basically, he's lying, and since he will not be able to present this, you slice the funds. Last but not least, the most difficult challenge, that is the read value challenge. So imagine that the lie is indeed in the read value. If you remember it, we are only hashing the right values. We don't have any memory in all this. In the paper of BitVM, they had all the memory in a Merkle tree, so they need to compute it each time. Here, we have not talked about memory until now, and indeed, there is no memory in BitVMX. The trick that's done here is that we consider that we know the state of the memory at the beginning. At the beginning, the memory is empty. So if we are reading a certain value from a certain address, it's either because it has the initial value, so 0, or it has been modified before. And if it has been modified before, since we have agreed on all the writes that has been done until one point in the array, we can go to the point where this value has been written and verify which value has been written at this exact step. So once this is done, there are two possibilities. And we used this last step kind of to be able to do this. Let's say that one party says, the party that's publishing this, says this position of memory has this value because the last time that was written was in this step. There are two possibilities here, that the published last step is greater than the last step. If it's greater, that means that the address that will be written in this published last step will be a different address as the one that has been published. The only thing that we need to, to do here is go to this published last step and verify that indeed the address that's being written is a different one than the one that's being published here. What if the published step is smaller than the real one? What we can do is go to the real last step, show that this last step is greater than the published one, and it's writing in the address that has been published, meaning that, indeed, the counterparty was lying in this last step because we are able to prove that there is a write in a last step that's bigger of the one published that contains the same address. And if you look at it, we have been able to take an execution, compute a hash, see where we had a discrepancy in this execution, and force one party to show all the information regarding this exact step, and then be able to check all the values that have been published. So either the values were correct, either we have a way to counterprove it. So making a little bit of summary, these are all the possible lies that one of the counterparties can say. There are these two at the end that I didn't mention, that basically at the beginning of the computation, the party that's publishing the hash also publishes the step at which the computation will end, and you can just check this going to this step and verifying that the program is ending. And the input value challenge, that's we're working on it, and it's basically the one that will, when you publish the result of the execution, you'll publish also the input that makes this program end up in a good manner. So basically, here what will be done is you'll have the snark verifier. The input will be the input that makes this verifier end up in true. And how do we build all this? If you remember it, we had all these transactions that have been pre-signed in such a way that we have all these publications. We reach a point. You need to choose a challenge following the connector schema that we had at the beginning. So what happens is you have these two parties, and the two parties generate all the public keys for the whole protocol, and they exchange them through the network. And here we'll talk about prover and verifier. The prover will be the one that locks the funds somewhere, and once he's able to give some proof to these funds, he will free the funds afterwards. The verifier will be the one that will be looking. If the proof that is presented is wrong, basically, will challenge the prover and slash the funds, or whatever mechanism you put in the bridge design or rollup, wherever. Keeping in mind that the verification system and the more complicated schema where you are using are detached from the thing that we said before, that this will just give you who's right or who's not right. So they exchange the public keys, and then the one that will lock the funds will sign all the transactions and will send all the signatures to the counterparty. The counterparty will generate all the transactions and will check that all the signatures are correct. If all the signatures are correct, say, OK, I have the same exact protocol, I sign everything, and I send my signatures to the counterparty. At this point, the prover has generated all the transactions and has all its signatures and the signatures of the counterparty. Since you have all the signatures of the counterparty, you are sure that you'll be able to publish all the messages. Since you are sure that you'll be able to do this, you trust kind of the configuration, and then and only then you lock the funds in the final address. Just in the moment, you'll be sure that you can end up the protocol correctly. I hope you, this has been a little bit intense. And now let's pass to a more calm part of the talk. Thanks to stay with me until here. So let's hope that we don't have the live effect, the demo effect today, and that everything works. So basically here we have two microservices that are running in my laptop, but this could be could be running in AWS or wherever. Everything is fully Dockerized, blah, blah, blah. And we have the prover here and the verifier here. If we come here, we have a Swagger, and basically, we only have two calls. This one, that will generate all the setup, following the thing that I told before. So the prover will generate all the public keys, will send them to the, well, I will explain as it happens because it takes a little bit. The only thing that you need to configure beforehand, is how many bits you will use to perform the search, and how many steps will have the computation. So in here, we are just doing a toy computation because the big computation take more to generate all the tree. We'll say that we have 1,000 steps, and we'll use 2 bits to choose to separate the wrong hashes, meaning that at each time, we'll separate the search space in 4 intervals. So now, if I click here, what just happened is that we'll start seeing that these two are talking one to the other, and things that start passing. And basically, the prover will send all the public keys to the verifier. The verifier will take these public keys, and with these public keys, you are already able to generate all the transactions, putting in each one of the transactions the values that you need. So this is happening. Now we see that the public keys have been correctly generated. The public keys now are sent back to the prover. The prover will take these public keys, will generate the whole tree of transactions, and will start signing all the transactions with its private key. Once this is done, he will send all the signatures to the verifier that will take all the transactions generated with the public keys that have received before and check that the signatures are correct. Keep in mind that since we are just sending the signatures and not the private key, the whole graph cannot be changed unless all the parties collide, because each one of the transactions is signed by the private key of all the parties. So now we see that the signatures endpoint is 200. It has responded here. So luckily, yeah, we have the setup fund 200. So if we come, this was interacting with Mutiny network that, for those who don't know it, it's a super cool network to make demos and development, because it's just a regular Bitcoin network, but with a confirmation time of 30 seconds, and a faucet that allows you to ask as many Bitcoins as you want. Because even in testnet, it's pretty tough to get testnet BTC, and if you want to have these kind of things live, it's not really easy. So if now we refresh, you see that the network that's not really being used. So we see one transaction here, 2, 1, 1, 2. What happened here is that in this transaction, I took funds from the faucet. And is this transaction here. So what I've done is I went to the faucet and took these BTCs and locked them in an address that's controlled by the prover. Then all this protocol started at this point here. And here, the setup phase ended up, meaning that, OK, at this point, we agreed on all these transactions, signatures, blah, blah. So the prover is sure that he can actually lock the funds in the address containing the protocol. And this is this transference here. We only lock the funds once we know that everything is correct. We don't need to lock them before. And now, for those who want to share this website here, BitVMX-explorer.com, I did this to make things a little bit easier. So if we come here and we copy this transaction here, we are in Mutiny.net, but we see this. So basically, this is the legend. The yellow stands for the funding transaction, the green for the transaction published by the prover, and the blue for the transaction published by the verifier. We only see the funding transaction because it's the only thing that we have done. And now, what we can say is that, OK, this setup that we have done now has this identifier. And there's another endpoint. It's pretty simple. What we are doing here is we are saying to the prover, OK, now trigger the protocol. And if the two parties are not malicious and are executing everything well, this has no sense because they will publish the last hash. The last hash will be exactly the same, and the protocol will not be triggered. And I'm doing a super small computation. It's like I take advantage to come here. If you come here, here there are 3 articles super interesting from Martin Jonas. That's the guy that has led the implementation of the emulator. And he has done an example script with kind of the more tough executions that you can have, like a read that is not aligned in C++, so he could test the emulator, but it's a super toy execution that's doing nothing, basically. But that has these things of, OK, what happens if you are trying to read a position in memory that is not aligned and it's taking 2 of them? This allowed him to kind of proof test that the emulator is working correctly.
It shows the worst case of the emulator and test it here.
Exactly, yeah. But it's super short. When we executed the snark verification, it was 4 billion of steps. Here, it's 1,000. The order of magnitude is much smaller. And OK, what I was saying is that if both parties say the same, there will be no triggering of the protocol. So what I've done is, in the code, you can tell to one of the parties, OK, you will lie in this step, and the kind of lie that you'll make is of this kind. So if you look here, what's set up now is that the verifier will lie in the step 345, and the kind of lie that he will publish is that when executing the code, he will make a wrong execution. So he will put in the output something that's wrong. And considering this, we can come here, just verify. Let me verify that. Copy this. So keep in mind that now we'll trigger the protocol, and the verifier will lie in the execution step. So now we call this, and if we come to Mutiny.net, what happened is that the prover executed everything, computed the hash, the verifier saw that the prover has published the hash, and did the execution, and verified that the hashes are different. And if we see here, we're starting to have a lot of transactions that contain all the things that I have been explaining before. So if we come here and we now refresh, we start having all these transactions. And if we look here, this is the raw witness. And if we look at it, we have basically, this is the value that is being published. And this is the Winternitz key that encodes this value. So we have de-encoding on all these hashes following the Winternitz that we just explained before. And I just did this, so that takes the raw input and simplifies it. So what we are doing here is, in the first transaction, we are publishing the hash result. In here, the verifier just executes everything and says, OK, I don't trust you. So now, show me intermediate states. So now we'll start showing these 3 hashes, because if you remember it, we put 2 bytes to make the choice. So since we have the last value and the first one, in order to divide by 4 the search space, we need to publish 3 values. And from now on, we have these 3 values. We choose which interval we want to follow. Then the prover will publish 3 values. And since we need this choice afterwards, here what we are doing is the cross signature that I was explaining before. So in order to show it, I have taken all the public keys that are being used, I concatenate them, and I hash them together. And I put the value here. So basically, you can see that this 0, 1 has been published with 1 keys that has start by C01. These are the Winternitz keys from the verifier. And here we have the same exact thing, C01. So this 01 is published with the keys from the verifier, but this 01 is published with the keys of the prover. Since the script checks that these 2 values must be equal, the prover can only publish the same exact value that has been published before. And this is how we are able to pass this 01 from one script to the other and force this party to publish this exact value. Now, if we continue going, you'll see all the time that is 1 choice, some hashes, 1 choice, some hashes. And luckily, this has already ended. Yeah. So I will refresh it. And you can come here. This is because I know it. At this step is the last choice. And basically here we are forcing the party to publish all the values that I was talking before. These are the, if you remember it, we had this read address value, read 1 address value, read 2 address value, and we had the values that are written, and we have here all these values decomposed following the Winternitz codification. Then the verifier says, OK, looks. In this step here, what will happen is that the verifier looks at the trace that has been published and says, OK, this is not correct, but for which reason? And here, what's being done is detect that the execution was not correct. So there's a tree of transactions. The verifier is choosing the execution path. And then the prover can come here and publish this, that will actually perform a RISC-V execution on chain. If we come here to the code, this is the execution of this exact instruction on chain.
How many kilobytes?
Yeah, 11.
11 kilobytes.
Yeah, it's here. Yeah, it's super small, indeed. And that's a little bit all. Just one thing, last thing to show kind of graphically how these Winternitz signatures work. And so this is what is being published in the witness. So if we take this corresponds to the value 3. And this is the maximum amount of values that we are encoding. So if we open, I just go like this, and we run it once, and we take this. This is the public key that is in the script. If we copy this and we go to the code and we look for it, we have indeed this. So what the script does is it takes this value, it hashes it, and verifies that in this position of the hashing, there's this key here. And we can see, because now we did it just once, so we said the maximum is 4. For the 0 will be the same exact thing. The only thing is that now we need to hash it 1, 2, 3, 4. And if we come to this 4, we come to the code, bingo, we have it again. So this is how Winternitz works. And that's all on my side. I don't know if you have any question. Thanks for staying until now and not fall asleep.
Well, thank you very much, Ramon. This was very ambitious and very broad. According to the schedule, you're supposed to go for 30 minutes and have a 30-minute break, but it seems like you went for 1 hour, and that was very impressive. So thank you for this. I feel like I've learned something new. I have to really compare these signatures with Lamport, which seem to have been very much promoted. Actually, yeah, you could provide an explanation why these signatures were used instead of Lamport. I know that Veronica asked you the same question and she went out, but maybe for the people watching on live stream.
Basically, the Lamport are the Winternitz with just one hash. So instead, here we were encoding 4 values in one public key. In the example that I just shown here, that I was hashing it 4 times. If one public key only encodes 1 value, this is equal to the Lamport. So you would have 1 public key for the 0, 1 public key for the 1, 1 public key for the 2, 1 public key for the 3. This basically allows you to optimize the space, but the key idea is exactly the same.
So the only question is at this point, where can people read more about this and maybe find a more succinct explanation of everything?
If you go to, well, there's the BitVMX website. You can go to the Explorer, and in the Explorer you'll find here the demo that we did when we published this on mainnet, the white paper where all that I explained is explained better, let's say, in a more academic way. And these articles that we are writing, where we are basically explaining all these pieces, but isolated in articles, so it's more affordable for a reader, because having everything at once can be a little bit intense. So it's like 1 article for Winternitz, 1 article for the challenges, 1 article for everything. And once you have this, if you come to protocol and you erase this, we have loaded some examples, so you can see how an execution challenge looks like. You click here, and you will have a trace. How a hash challenge looks like, and you have the trace. And with the paper in one side and this on the other, you should be able to more or less follow what's happening in the blockchain.
Well, Janus is up next, but he's getting mic'd right now, so I'll ask you another question. I guess there are people watching this and wondering, what is the point of it? How can the average user make use of what you presented to build something? And what would be some potential use cases?
So for me, the cool part of it is that you can run every compiled program, so you can build a rollup in Rust instead of making everything on a snark, blah, blah. So everything that you can build in a compilable program, you can run it here. For me, it's the main advantage regarding BitVM2, that you really need to get into the snarks, and everything is coded in Bitcoin script, which is pretty heavy and pretty difficult. In here, you can have everything in Rust or C++, compile it, and have it on Bitcoin. So you could build everything that you imagine in a compilable programming language and use our framework.
All right, thank you very much. Round of applause for Ramon once again. Janus, you want to get on stage now? Yes, sir.
Let's do this. I got it.
this next presentation is about Bitcoin Layer 2s and how they contribute to the security budget of Bitcoin. And I know that's a big talking point because, for example, the Lightning Network is a way for you to open payment channels, but at the same time, when you do Lightning transactions, you're not contributing to the security budget in any way. You do have drive chains, which are an idea for you to do side chains that are two-way pegged and which pay transactions to the Bitcoin miners. But maybe that there are some other ways, and Janus, who is right here and he's getting his slides ready, is going to tell us all about it. Can we get like 2 minutes so we can all get drinks and come back?
Yeah, 2 minutes is fine. Go ahead.
Until you
Yeah,
set up.
I'll wait. Yeah, no worries.
Yeah. We're going to be back.
I hope they have the intermission music going. Actually, does this work? Good to go. I will wait 30 more seconds for maybe one more person to come in, and then you guys will get to hear my semantics rant. It's probably good that people aren't here because I'm yelling at everyone. I'll be yelling at everyone in this talk. So the less people here, the better. So we'll start, and I'll start in 30 seconds.
It's funny how you phrased it, right? Because on the website proposal it says layer 2s and the security budget.
Well, yeah.
But at the time it said they need to pay Bitcoin miners money.
Yeah, I changed it because I'm writing like a lot of like a really long like blog on why L2s aren't L2s in terms of like sidechains and rollups, and yeah, so that's what I'm going to explain today and why they need to pay money to people. So yeah, I think that's a good segue. I'll go ahead and get started. My name's Janus. I'm doing a talk today on why L2s need to pay Bitcoin miners money. My argument is that L2 specifically to like sidechains and rollups. One of our researchers, Veronica, gave a talk yesterday on like ARC and touched on Lightning and shielded CSV. So I'm going to focus on sidechains and rollups today. I'm going to argue that these are actually sovereign, like layer 1 type blockchain systems, and their relationship as an L2 with Bitcoin only is that of Bitcoin, the asset. And they need to make sure that that asset always retains value. So paying to the, contributing to the security budget is part of that. There are no outcomes in this talk. I'm gonna make a bunch of claims and make a bunch of arguments, but I'm not actually, and I'm gonna yell at everybody, but I'm not actually gonna suggest to do anything different. Well, I am suggesting one thing, but it's not like there's any direct outcome. So I'm sorry that you're just gonna hear me ramble for 25 minutes. My name's Janus. I work on the Bitcoin Layers project. I used to work on Zcash and Espresso. Espresso is like a shared sequencer protocol in Ethereum. I want Zcash on Bitcoin. And the reason I want Zcash on Bitcoin is because I think that Zcash privacy is really cool. But I'm also very interested in things like fair launch, proof of work, and capped issuance, which Zcash didn't have a fair launch. It's shifting to proof of stake, and we don't know if Zcash will be able to have capped issuance due to not being able to sustain its own fee environment. So I am now looking at how we can maybe do Zcash-style second layers on Bitcoin. So from ChatGPT, the Bitcoin security budget refers to the total amount of financial resources dedicated to maintaining the security and the integrity of the Bitcoin network. And we want to make sure that the Bitcoin network has the security and integrity so we can always have a valuable Bitcoin asset. And what I'm using for a layer 2 definition today is a layer 2 is a protocol that takes transaction execution off-chain and enables any user to ensure the integrity of a two-way peg. What I mean by that is by a two-way peg, you have some multi-sig where all the Bitcoin is stored, and if someone tried to be malicious and steal that money, any Bitcoin full node or any user could be able to submit a challenge transaction to stop them from stealing the money. When we think about layer 2s, bridges aren't actually real. This is the Brooklyn Bridge, and that's a real bridge, but blockchain bridges aren't real. They don't exist. What we actually are doing is we're having a two-way peg where we use L1 assets on a smart contract on the L1 chain to mint and burn tokens that are L2 tokens on another system, like, for example, wrap Bitcoin on Ethereum. If this peg is broken and L2 assets, if this peg is broken and all the money is removed from this L1 smart contract, the L2 tokens still exist. So there's still WBTC if the money backing it is completely gone. That token still exists on the sidechain. And L2s, in some scenarios, because they're sovereign systems, might want to hard fork and break the official two-way peg. So for example, you have a roll-up smart contract or a roll-up style bridge. You might want to break away from that bridge and devalue Bitcoin assets on your chain if your native token, for example, has a much higher market cap, it is more valuable. And that layer 2 token, let's say there's a smart contract hack and 80% of the supply goes to a malicious actor. You can have scenarios where an L2 or sidechain type system would want to hard fork, break away from the two-way peg, and start a new chain to revert the state to give everybody access back to the L2 asset because it's more valuable than the L1 asset. So my argument with this point here is that L2s are only L2s in relationship with the specific asset that you hold on the chain. If you're holding an L2 asset and that's the only one you interact with, you're actually interacting with a system more similar to a layer 1 blockchain. The reason we need to have these L2 systems sustain the fee environment is because we have really small blocks in Bitcoin, and issuance halves every 4 years. So we have small blocks, so we need L2s and to take transaction execution off chain because it won't scale. Issuance halves every 4 years. It's going to eventually stop, so there's not going to be newly issued coins to miners to incentivize them to secure the network. So we need fees to make up the difference. And my thesis is that if we need L2s because of the small blocks and we need a lot of fees, we need to have L2s put a lot of stuff on chain to incentivize miners and also sustain the security budget. Additionally, I don't think the term of settlement layer is an actually good way to look at Bitcoin. And a good way to look at how we're defining L2s. The finality of the L1 asset is always enforced by the two-way peg mechanism. So that's why we're trying to build things like BitVM, BitVMX, BitVM2, etc., because we want to have a validating bridge that enforces the validity of all withdrawals and ensure those withdrawals are going to the correct users when they leave the system. Bitcoin cannot enforce L2 finality based on the data there. This is true of roll-up sequencer batches. This is true of state roots that maybe a sidechain will post on and anchor to the Bitcoin chain. Bitcoin, this is arbitrary data, and Bitcoin itself is not enforcing any finality or reorg resistance. It's the L2 consensus mechanism that forces that. So it's the L2 consensus mechanism pointing to a specific point on the chain and then building upon that. So I just want to really say quickly that when we're thinking about L2s, we're not looking at it as them inheriting kind of network security from Bitcoin. We're only inheriting security with regards to the Bitcoin asset. So when we look at some of the L2s, this is Lightning McQueen. I don't know if you guys have seen Cars. But this is the Lightning Network. We'll just touch on this. Transaction execution off-chain to it, you can ensure the integrity of a two-way peg or your payment channel if your counterparty becomes malicious. And your fees paid to the network are to open and close channels. We're not entirely sure if this is like the most fee revenue intensive mechanism to sustain the security budget long term. So we have these different types of solutions. So we have roll-ups. They have transaction execution on chain. They can have two-way pegs where the integrity of the chain, the integrity of the peg is done on chain. They can also have federations, like a roll-up can have a federated two-way peg, just like a sidechain can. And the fees that are paid to the miners are fees to post all of the transaction data in a sequencer batch and also a validity proof or a fraud proof on chain. Validiums. This is birds aren't real. I don't know if you guys have seen that. But like birds aren't real, validiums aren't real. I don't think they're real. Some people do. But for the sake of the conversation, we'll describe them. They do transaction execution off-chain. You can ensure the integrity of a two-way peg on-chain, but the data availability system, because the data is being posted onto another system, can withhold the data, so you can't process withdrawals. And then the proofs containing the latest state root and proof of execution are posted on chain. If you do something like Groth 16, that's like maybe like 200 bytes, like every 8 hours or so would be kind of what you would be posting on chain in this mechanism. And then we have sidechains. You also have transaction execution off chain. You have the two-way peg integrity can be enforced on chain in some mechanisms. I think BitVMX is going to be the first time that someone in a sidechain style system is trying to do this. You can earn fees in a sidechain via merge mining. I would say that's like probably the most straightforward way. And then additionally, you can do things like Stacks does and like post a state root on chain every periodically as well. So when we look at these systems, though, I think we're conflating all of these things and trying to say that they're different. Rollups are sidechains. They're blockchains with their own full node software. They can hard fork. They can make decisions as a social system. They can hard fork away from the L1 that they use for DA. Validiums, additionally, are sidechains because they're rollups to other blockchains that have a kind of official enshrined two-way peg with Bitcoin. And sidechains are sidechains. The reason we say that rollups can potentially be L2s, maybe if we even tighten that definition to say it's a unilateral exit definition for L2, is because if there's like a soft fork on Bitcoin and you can actually verify the state transition in script directly, then a user might be able to bypass like a bridge operator set to withdraw their funds from a bridge contract. But in all systems today, with BitVM, et cetera, none of these systems I would say are L2s in that definition, but they are L2s in the sense that anybody can ensure the integrity of a two-way peg if they have the correct type of bridge mechanism in place. So what is Bitcoin and its relationship with L2s? Like we mentioned earlier, it's not the settlement layer. So what is the actual relationship with Bitcoin? It's a decentralized network that we have all socially agreed to value and socially agreed to opt into with a pristine asset due to the economics behind the asset. We want to use this asset on other networks for monetary purposes because we value the asset and we cannot transact with this asset directly on the Bitcoin L1. Again, it doesn't enforce L2 finality, but it can enforce the validity of withdrawals from bridge programs if the bridge program is constructed correctly. So when we look at Bitcoin and its relationship as a main chain with L2s, the L2 relationship is always dependent on the bridge program that you have in place, and if the Bitcoin consensus participants have the ability to enforce the validity of withdrawals. So let's talk about something that is related to the security of two-way pegs in some scenarios, data availability. So data availability is essentially, for a side system, is making the data available to some set of consensus participants for some certain amount of time. Typically, in some systems, this is the amount of time that you would need to construct a fraud proof. So maybe data availability is made available every 2 weeks. So anybody, if they need to construct a fraud proof before the challenge period times out, they have the data and are able to do that. Data availability on Bitcoin is very scarce. We only have, like we mentioned, 4 megabytes of data available every 10 minutes. And if we have rollups and validiums and sidechains and all these different types of systems trying to throw proofs and throw sequencer batches on chain, that becomes very, very competitive and very expensive. So if you look at Ethereum with the Ethereum blobs, which was recently implemented, I think, this year, that's 9 times, has 9 times more throughput, and then Celestia currently has 23 times more throughput, and Celestia is even trying to go to like 1 gigabyte blocks. And they're making a trade-off with that to implement another mechanism where they have more secure light clients, but they're trying to even make the blocks even bigger, which would make more data available and make it cheaper to post sequencer data or proofs on chain. So when we look at like rollups specifically, and like we mentioned earlier, rollups can be quite secure, but it comes at a cost. So if we're posting 400 kilobytes on chain, every 6 blocks is what this chart is showing. That can be very, very expensive. And like at a 10 sat for a vbyte environment, that's like 450,000, and 50 sat per vbyte can go up to 2.3 million. And these costs are always taken back down to the user. So if you only have 50,000 transactions a month, because this chart below is based on the 400 kilobytes, the user for even in a low fee environment is going to be paying $10 per transaction. And then, if there's more transactions, obviously those costs are distributed across the user set. But there are ways to optimize this. There are ways to, if you use certain data compression techniques, you don't have to post like the full sequencer batch. You can just post the differentials in state, which would make this a little bit cheaper. But still, long term, this is going to be a very, very costly thing. So why would you want to do that? Because if you post the data to Bitcoin directly, you do maintain the highest level of security for users of Bitcoin assets. It does provide that consistent fee revenue for miners. You have minimal trust assumptions outside of your Bitcoin full node. With regards to like being able to verify the data and reconstruct the state of the system. And in these systems, a lot of the times, there's no reliance on another token or inflationary economic models, because if the data is on Bitcoin and you enable the user to bypass a sequencer or bypass a validator set, which you need to make the data on Bitcoin to make them available, to make them able to do that, you don't need to actually build a decentralized consensus set and incentivize them with another token, because the users can unilaterally exit to the or force include their transactions to the L1 miner set. And if the sequencer doesn't include that transaction in the next block, they'd be slashed. So we have the ability to put a lot of pressure on the sequencer to make sure that it doesn't censor in this model. But that very theoretical world where we can have a single validator and not have to build a distributed consensus set only works in some scenarios. So if we look here, if the rollup doesn't have forced inclusion and doesn't have the ability to self-propose your own state transition and has a centralized rollup operator, your trust assumption is completely dependent on the single rollup operator, the one node. And if you can't bypass that, your liveness and the ability to get your money out is dependent on one entity. If you do have forced inclusion and have no self-proposing, and you have a centralized rollup operator, you're still dependent on the rollup operator, and that can be better than a sidechain in some scenarios, but only if the rollup has to post a bond, and if they don't force include transactions in the subsequent block, they get slashed. So if they don't have that in place, then it's not better in the sidechain. If they do have that in place, well, you can make an argument that it is. And then if you have forced inclusion, self-proposing, and then a centralized operator, we could argue that it's better than a traditional sidechain in sense of a sidechain with no data availability on Bitcoin. But then if you get to no centralized operators, you have, if you have self-proposing and forced inclusion, we would say that's better. But if you don't have forced inclusion and you don't have self-proposing, but you have a decentralized sequencer set, it's the same exact thing as a sidechain in the regards of a trust assumption related to getting your assets out of the side system. So the data availability is important, and having that data on chain is important only if it enables a user to self-propose their own state transition. And if they're not able to do that, then it's kind of a moot point. And we should also clarify that there's no in-production rollups on Bitcoin today, and in Ethereum, I think 1 out of 70 rollups has forced inclusion and self-proposing enabled. I think there's about 10 that have, there's 2 rollups that enable this, and I think there's maybe 10 to 12 that enable forced inclusion. We do really key point that in the sidechain family, within maybe Rootstock or Liquid or some other mechanism, unavailable blocks can be orphaned. So if there's a data withholding attack, it's kind of ineffective because they're incentivized to post their blocks on chain, so they can get block rewards. This is a bit different than a Validium model, because the Validium model, if the value of the money locked in the bridge contract is greater than that of the money that these validators can make from block rewards, and they're incentivized to freeze the data and try to steal the money included with the sequencer. That's not really the case in traditional sidechains. But I'm going to make an argument right now that why should we not have execution environments that are merge-mined sidechains? I would say that you have more trust assumptions outside of your Bitcoin full node for DA, but I want to say that's kind of more of a moot point in this sense, because DA long-term, like we just mentioned, is not as scalable and sustainable. You can't bypass the L2 validator miners for exit. So even if you have a merge-mined sidechain, you are relying on the sidechain kind of mechanism to be able to include your transaction in the sidechain block, and then go to the bridge to withdraw your funds. There is opportunity to extract MEV in really high fee revenue environments. And then we also have this question of like, can merge mining survive long-term only on fees? Sorry, we're not to the but yet, sorry. I thought I jumped ahead of myself. And also additionally, we need to remember that blockchains don't scale. No blockchain scales, and when we're talking about scaling, we're talking about more throughput. More throughput isn't scaling. Even if we have a roll-up with a centralized sequencer, we're not scaling anything. We're just taking a bunch of data and we're throwing it in another big box and just increasing the throughput. And you get more throughput by bigger boxes, and more bigger boxes means less user validation of the network state. Blockchains don't scale. But we don't have to scale every blockchain. So when we're talking about merge mining, right, and merge mine DA, or even Bitcoin DA, we have this like now weird thing where we have merge mined kind of side chains with transaction execution on-chain directly. Is not always the most scalable system, but we could do something where we have merge mine DA. So what we can do is we can make a trade-off, kind of noted here, that we can make a trade-off by having a really secure bridge contract on the L1, and we can put DA onto another system that's more aligned with Bitcoin, whether that's a merge mine DA or a proof-of-stake DA type system. And we can basically create a trade-off mechanism for like more higher value transactions. Let's say it's like a really high value financial like kind of system. We can maybe use Bitcoin DA for that. But if it's a more kind of everyday type of use case, we can use merge mine DA or more Bitcoin aligned DA like NewBit, which is doing some proof of stake mechanism for users who don't need that full level of security. So we can have a bit of a trade-off spectrum here. So why merge mine a DA layer? And I think this is where it gets really, really interesting. When you look at the trend of kind of what applications want, and I would say this is the very much case of like all modular ecosystems. Applications want to own their own ordering policy. They want to be able to have their own building policy for transactions. They want to be able to earn fees directly on the transactions that they're providing into a specific ecosystem, and they want to be able to make that revenue. Miners in that situation, if they're merge mining a DA layer, they have no influence directly on the transaction ordering of a specific chain, and they can't extract MEV. And reorder transactions. You separate TX ordering from data availability. You can provide a better UX, so you can provide faster block times and transaction confirmation times. Note that these are pre-confirmations. They still have to be validated by the DA layer or the merge mine system in this example. But a lot of the times, these pre-confirmations do end up going through. And teams, what I'm arguing also is that they don't have to launch a token to be sustainable. Because if you can just run your sequencer, you can make pretty good money. And we can just use big boxes. We can have one event trust assumption for data availability, and we can just have the sequencer and use really big boxes as centralized validators to these chains. But I will add that we need to have some mechanism for a user to be able to access the data and then also take that data and be able to propose a state transition directly to bridge contracts to make this actually work. So, and just to touch on the revenue, if you look at September, CBBTC just launched, and the base sequencer is making nearly $50,000 right now on CBBTC transactions alone. So if you actually have like a useful application that drives a lot of usage to your network, you can actually make a lot of money off sequencer fees, and you don't need to launch your own token to be sustainable. So I do want to go back to this though, on this like use big boxes trust assumption mechanism. So if you look at Rootstock, for example, Rootstock can make a more modular trade-off than the Bitcoin layer does. It can have potentially bigger blocks. It can implement something like blobs. And what we can do is we can have BitVMX as the bridge contract, which has that one event trust assumption that we love. So the user assumption now is if they can self-propose their own state transition, is if they get censored by a sequencer in this own application layer, they can bypass the sequencer, retrieve the data from a Rootstock full node, and then post their state transition with that data to the bridge contract on Bitcoin to exit the system. There's a few different trust assumptions there, but when you look at modularly, as long as you can bypass the sequencer, it's a relatively strong trust assumption, and maybe only if you're having like $500,000, $600,000 transactions, or maybe less than that, maybe like 10,000, more high value transactions, maybe you want to use Bitcoin for DA. Just to ensure that data is always available. But the more kind of normal the use case, maybe merge mine DA is a trade-off that we're willing to make. So that was a lot. Jumped over a few places. I want to give a TLDR to kind of explain how I'm thinking about this. is that high-value transactions and high-value financial systems should always be used in a system where their guarantee is always dependent on a Bitcoin full node and the trust assumption related to the individual bridge contract. If that's BitVM2, BitVMX, etc., we have a one-event trust assumption and potentially permissionless challenging. So it would match that definition of an L2 that we gave earlier on any user being able to interact with a two-way peg. Most users will interact with systems that use off-chain DA because we talked about earlier that Bitcoin DA is not always scalable. But this is also the case for rollups. Rollups can also enable kind of like execution environments that support other chains, and so can side chains. So when we think about side chains and potentially rollups being kind of more layers where these rollup smart contracts live, we can build a system where we have merge mine DAs and merge mine the data availability layer to kind of create some incentive for miners to always have sustainable fee revenue. And if we have applications that own their own sequencing and are providing a lot of value and have more application-tailored specific VMs, we can build better applications than what we can build on general-purpose environments. We can drive more users to these systems. And these applications own their own sequencing. They get to make money off running their own centralized sequencer. But we're still inheriting the security of the DA layer and the bridge contract, respectively. So I think when we think about the application layer in the future, we want to be able to democratize teams to be able to have more authority over their ordering policy. I think decentralization for a lot of these application layers is kind of a meme in the sense. I don't think we always need to have a decentralized validator system for pre-confirmations, but we always need to retain the ability to have a very, very trust minimized DA layer and also a very native bridge contract on the L1 where anybody can challenge bridge operators that are trying to steal money from the system. So that's my argument. I think we should build towards rollups and then systems that support very application-specific chains where apps can have their own sequencing and apps can tailor their execution environments to specific use cases. So yeah, and all of that we need to do to ensure that we are incentivizing miners long-term because we want to use Bitcoin, the asset, on these chains, and that is our relationship with them as an L2. And we need to ensure that that this is sustainable, so we need to make sure that we're sustaining the security budget to make sure we retain a fixed supply of 21 million and ensure that, yeah, we can use Bitcoin on these systems long term. So that's my talk. Any questions? Yeah, go ahead.
So for like merge mine DA layer, I think the main thing about like data availability committee and DA layer is that, for example, in Celestic array, there's a token that these validators stake, and they make the data available. And the main purpose of the token is if they attack to a rollup bridge by just withholding the data and publishing blocks without any, just publishing headers without publishing blocks. Eventually, social consensus can fall back and slash those tokens of these validators so that we can compensate for the bridge attack for the rollup. But for merge mine DA layers, there is nothing at stake. So if they attack to the rollup bridge and make the data unavailable, then at the end, even though you just fall back to the social consensus, you cannot slash anything. You cannot just take them as is from their phone. So that's, I think, the main blocker for merge mine DA layers.
Yeah, so I think the argument against that is just like long term, are the economic models of the DA layers going to be sustainable, and are they going to earn enough revenue in order to kind of incentivize people to hold the token and and incentivize them to hold the token and kind of value the token and stake and secure the network. I think we're very early on systems like Avail and Celestia to see if those work long term. The argument I'm kind of making here is that we can have an alternative. I don't think using Celestia is like a terrible trust assumption. I actually, like in the text, like really, really cool. But here, if we can try to use like these DA layers and try to have more application-specific VMs, maybe we can, with better application layers, we can introduce more user transactions, more onboarding, and then that can sustainably like pay sustain revenue where we're posting the sequencer batches on chain to these DA layers. I think you can also make trade-offs. Like you don't have to blow up the block size. Like you can have smaller blocks dependent on, and this is kind of like a trade-off space we need to explore more. But if you have smaller blocks, then it's more expensive to post your data there, but you get the advantage of having more full nodes available to be able to validate and store the data and make that available as well. So I think it's like a trade-off space, but I would agree that there is more of a incentive right now to run like a Celestia node than try to merge mine DA feeds off a sidechain. But long term, I don't know if that's the case, and I don't think we've tried the economics of just trying to build really good application layers yet to see if we can create enough transaction volume to not have to use another token. Any other questions? Cool. Thanks, guys.
Thank you very much, Janus.
Yeah,
this
thanks.
was refreshing. There should be a T-shirt that says "Sidechains are sidechains." I think that was very cool.
Yeah.
And you spoke about data availability, and the next speaker is going to talk about putting data on the Bitcoin blockchain and the history of non-monetary uses. His name is Theo Goodman. He usually does these art galleries and auctions for tokens, and I got to actually ask him to join because he's outside.
Cool. Yeah, I'm gonna get my
So
stuff.
Theo, join us on stage.
Oh, we're doing the panel first?
Yeah. Yeah. Ian, nice to meet you.
Wave a little light of love so I can get to you. Open up your heart and soul so I can see through you.
We're green. Ladies and gentlemen, we are now live on the internet and in Spark, Frankfurt. Welcome, welcome. Please join us. Please join us. Welcome. We've got a huge crowd here, ladies and gentlemen, tonight. This is the moment you've all been waiting for. This is the talk by none other than Theo Goodman. Woo! Yeah, the crowd goes wild. The crowd goes wild. You guys online don't see, but we've got 500 people watching me right here. Yeah, this is, really fucking amazing. And as you notice on the screen, humans have been speaking and communicating through picture words since the dawn of time, just as the Egyptians spoke, just as the cavemen carved things into the cave, so do we today use emojis and memes, because they can communicate a word and an idea faster than the spoken or written word, oftentimes, to communicate a concept. And we've seen that over time till today. And also with Bitcoin. So when Satoshi created the Genesis block, he embedded a message into the Genesis block. So in some ways, you could argue that one of the first uses of Bitcoin was non-monetary, because simply embedding a message into the Genesis block itself is not a monetary use of Bitcoin. But it's not the first time that people used a monetary system to communicate concepts that are non-monetary, or even to communicate memes. Because just the quote, "Chancellor on the brink of second bailout for banks," in itself is a meme that has propagated throughout all of our thoughts till today. That phrase itself and what it symbolizes is one of the reasons that we're here today, that non-monetary communication. This is some Roman coinage. And so the Romans did not have internet. But they did have a monetary network that spanned deep throughout the empire, because all of the places that they took over were forced to use Roman currency. So how did they propagate their propaganda, or as we would today say, their memes, throughout the Roman Empire? Well, on the back of the coins. They often changed the minting of the back of the coin, and they knew that that would spread a message throughout the Roman Empire, all the way through it. So here we have one at the bottom, and it's just talking about the empress is pregnant, and she is somehow related to a Roman god. I don't remember which one. And here we have one, it's about the Gauls. So this is the Romans conquering the Gauls. So they wanted to propagate this meme throughout the empire using their monetary network that we are superior, we have kicked ass, watch out, you must, be humble around us, etc. So if you think about it, this is not a lot different. This is almost the exact same thing. Essentially, what Satoshi did when he put this in the Genesis block is he wrote on the back of a coin, in a sense, in a very similar way. And that's essentially what people are doing when they make things like this. And they use Bitcoin. On these examples, these are Bitcoin tokens that have images assigned with them. Now, the network just thinks it's just a Bitcoin transaction. The network doesn't see necessarily these pictures. It just looks at them as Bitcoin transactions. But you can imagine it's basically the same as writing on the back of a dollar bill with a specific serial number, or writing on the back of a coin, and then that is able to propagate throughout that monetary network. So technically, it's a non-monetary use, but it's using a monetary network for the spread of it. Here's some other fine artwork of mine. I just thought I'd take this moment to shill it. These are some of my series, Ugly Lines. It's some highly sophisticated modern art. And there's other non-monetary use cases of blockchain, Bitcoin, whatever you want to call it, and those are DAOs. Now, DAOs, the governance is not that bad. Well, we know a lot of the governance is complete garbage. Most of them are complete garbage. But, let's just mention a few that you might have heard of. BISC, they actually have a DAO. You might have heard of that client. It's actually a client. It actually runs on Tor. It enables Bitcoin fiat on and off ramps. Pretty cool, but they have a DAO. That's how they're able to maintain things. You might have heard of DarkFi. It's a project around privacy. And they also have a DAO. So these are non-monetary use cases of blockchain or Bitcoin. BISC actually also has a token on Bitcoin, so a colored coin that enables the DAO to function. Layer 2s. You say, well, Theo, what the fuck? Layer 2 is a layer 2. Yeah, but each layer 2 has to anchor to the layer 1 at some point, or most of them do, right? That's the whole point of a layer 2. So all of the non-monetary stuff on the layer 2 that happens, so all of the PEPEs, all of the NFTs, all the gaming, all of that stuff you say, hey, it actually is on layer 1 too via the anchor transaction. So layer 2 is also, this anchoring process is also a non-monetary use if the non-monetary use happened on layer 2. Timestamps. You could timestamp anything and put it on Bitcoin. It's not a monetary use either, right? It's really exciting too. It's almost exciting as this slide. And there is another discussion, about Satoshis. Do Satoshis exist? What do you think? Do Satoshis exist, sir?
Depends on.
Depends? Perspective? What do you think? No. No?
There's no discrete Satoshi.
Okay, great. Roman, what do you think?
I think there is discrete Satoshi.
He does. So we have, okay. Sir? No? What do you think? Abstain? Yes. Vlad? Satoshi's.
Satoshis, but you mostly find them in Japan.
Okay. Cornholio? Yes. They exist. So we have almost a 50-50 thing. And, it doesn't really matter because the network doesn't care. The network doesn't care. And it's so funny because people that are really hardcore on this side, Satoshis exist, and they must use a lens to see them. Yeah? Okay. But the Satoshis don't exist. Well, in the end, it's also a lens to not see them. So you're both just looking at the network in a different way. It's a matter of, hey, you're going to play by my rules, or I'm going to say which rules are correct to interpret these transactions. But you know what? In the end, the network doesn't care. Welcome. Welcome. We really appreciate you coming. We've got a full house today. We're getting into some really serious stuff. Sir, I have a hot question for you. Do you think Satoshis exist? Yes or no? Do sats exist?
Yes.
Yes. Okay. Ooh, I've got another good question. If sats don't exist, how do you stack sats? Yeah? One UTXO at a time. But just to mention, if we really want to get into because of course this is philosophical, it's technical too, because we're talking about lenses, but if everyone talking about stacking sats, and then the next day they say, hey, sats don't exist, kind of contradicts each other. So, maybe sats exist. My proposal is, okay, depends on how you look at it, but if we say sats exist, it's a cool meme. You can use it for stacking sats too. You don't have to use it for pictures and really awful things like that. Okay, this is another, as you can see, I'm going into really crazy topics. I really like the high quality of my slide here. But yeah, what if this, some of the, not the sats argument, what if some of the really hard core arguments are a psyop? Yeah, I'm just throwing it out there. What if they are? And so what this is something called COINTELPRO. So that was in the 60s and 70s in the United States. And COINTELPRO, counterintelligence program, and it was used to divide up the Black Panther Party from something called the Student Nonviolent Coordinating Committee. And so what's cool about it is because all of these documents are pretty old, they're unclassified. Then they do have blacked out parts, but we can just get an idea of what are some of the things that they did. You think it's James Bond and they went in to assassinate people, and yeah, they did some stuff like this. But here, they're basically inserting an idea into these organizations to divide them. What does he say? He says, there's a feud being continued by the Student Nonviolent Coordinating Committee, circulating the statement, according to zoologists, the main difference between a panther and other large cats is the panther has the smallest head. So literally the government did in fact successfully insert a meme saying, hey, this group said that your mascot has the smallest head in order to divide them. So just from deduction, if we know the government is willing to go through that much trouble just to start this kind of division, imagine what they're doing today. Yeah, imagine what they're doing today. So just next time you rage tweet, just think about it. Maybe you're part of the PSYOP. This is what, in my opinion, what Bitcoin Puritan life looks like. On some days you're like, yeah, HODL, the Bitcoin standard, sound money. You're welcome to join us. It's a fun party. So here, for everyone watching the live stream, we have kind of a zoo situation where we have this glass window and people are coming in like, oh, look, it's like animals in there. Like, what are they doing, It's kind of like a zoo situation. Welcome, welcome. Sir, I have an introductory question. Do sats exist? What do you think? Do Satoshis exist, sir? Okay, cool. He thinks so. Cool. Yeah, I like putting people on the spot. We're just doing some really scientific research here. This is what it looks like if you think non-monetary use is an attack on Bitcoin. This is just like what your everyday life will be in the future. This is my subjective opinion, but I think this is like what it looks like. Non-monetary use. This is what non-monetary use looks like. It's great. It's happy. Yeah? It's amazing. Like, look, yes. And just as we have in the Poor Pepe's Lambo historical 2017 Rare Pepe card, we have to read the advice that is given. It says, wise Pepe says, shill many Pepes, and you too will have a real Lambo one day. And of course, but look at the Lambo that he has. It's the Poor Pepe's Lambo. One of my favorite cards. Just take a moment to, Yeah, sometimes, welcome, sir, welcome. Sir, I have a question for you. Do Satoshis exist? Do sats exist, in your opinion? More or less. Okay, cool. We're getting some good research here. Yeah, but actually, this guy at, he's a non-monetary user. They're promoting meme coins just on a certain blockchain. But this is what non-monetary use of blockchain could look like. Yeah? Is this what I missed yesterday at this conference? Is this what the talks were like? Not really? No? Lots of dancing, showing abs? No? Hey, this guy. Yeah? But I just had to have a quote from him that I found. I thought that was pretty interesting. Bitcoin isn't just money. The blockchain isn't a system of currency, it's a platform of trust. So, how can I trust that I own one of these Poor Pepe's Lambo tokens? Or how can I trust, hey, welcome to the talk. I really appreciate you coming. I have a very important question. Do Satoshis exist? Do sats exist to you? Yes. Okay, cool. But how do I know that I own one of these pieces of fine art, right? I have to trust the system, the blockchain system, the Bitcoin blockchain. And as Andreas was saying, Bitcoin is not just money. The blockchain isn't just a system of currency, it's a platform of trust. Because I want to be able to trust that my Pepes are safe, for example. And here we are. Here we are again at the, hey, Jameson, how do you like your Pepe? Love it? Yeah, we've got Charlie Lee. I did not make this. I actually stole this artwork from Vlad's girlfriend and just added it. But I added in myself. Of course, that looks just like me. What do you guys think? Like this? Like this? If I go like this? Kind of, yeah? See the resemblance? Yeah. And I don't know, this has actually absolutely nothing to do with the talk except that they're Pepes, but I thought it was cool to include because a lot of talks are super boring. It might even be my last slide. So yeah, I had while we're on that slide, I had a few other things. Bitcoiners, 10 years ago, they were saying, separate money from the state. Fuck the system, And Bitcoiners today, when Trump says Bitcoin, they just like jizz in their pants, like that, It's kind of like they idolize Trump or Saylor to the point that they're basically the same kind of people that would go to a strip club and be like, the stripper loves me. Angel said she loves me. This is just some observations. I have to look. Layer 2s, they're kind of like someone you have an affair with. You're always connected in that anchor transaction. And then when they fuck up, you say, oh, that's the worst piece of shit ever. I hate them. I just worked on these jokes today. Hope you like them. Yes. Anyone looking for a job in Bitcoin? Swan is hiring, I heard. And there's some of the loudest proponents of non-monetary Bitcoin is horrible and all this shit. And then it turns out they were basically having a love affair with Tether, a totally custodial token mostly used on Tron blockchain. So it's just kind of, sometimes the loudest people you hear, might be doing, I guess you could call it a self-psyop, essentially, like they're scamming themselves. So just, think about that sometimes when things are going on. It might be loud for a reason. I kind of think that some of the loud people like that are extremely loud and can't understand any nuisance are it's like the spoiled kid that has a room full of toys. He says, you can't play with my toys unless you play with them like I say so, only by my rules. Just an observation I had. Anyway, actually, that concludes my talk. Do we have any questions about any of my wonderful slides or any other comments? I think we did some very highly scientific research today on do sats exist? And I've come to the conclusion it's about 50-50 in the room, actually, slightly leaning towards, would you like to come in? It's important. Okay, we're going to do a test. Watch this. I'm going to ask them when they come in. Watch this. Come on. Welcome to the talk. Hi.
All of your slides.
Great. I have a very important question. Do sats exist?
Do sats exist?
Yes.
Of course they do.
Of course they do. Okay, we have very strong, of course they do. Sir, do you think sats exist?
Do UTXOs exist?
That's a counter question. I have to prepare more slides for that. Hello, sir. Welcome. Do sats exist, sir? What do you think? Yes? Yes? Sir, do sats exist? Do Satoshis exist?
In what sense? Sorry.
That's a good one. Wow, we've got some really... So we've got two. In which sense? I think that boils down the whole argument. In which sense? And I think, what was the other one? Do UTXOs exist? I guess so, right? So we just have some new arrivals, and I think I have a whole 5 minutes left, so I'll just torture you guys. I just said that people have been communicating like this for a long time. The Egyptians communicated with pictures. And actually, I have minted this fine artwork using the Counterparty Protocol. It's a one of one. Back in the vintage days of 2020, I made this NFT thing, yeah. You probably are wondering who I am. You're like, who is this guy, Some people say, Theo, you look good. You look good. But then I realize it's just because I'm standing outside of the venue and they think I'm the bouncer. Yeah. Most people think that I look like an Iraq vet with PTSD that had to become a bouncer. And then he got hit in the head so many times, and now he thinks he's an NFT artist.
I like the NFT.
Yeah. So, guess what? Just quick review. Don't worry. I know all of you are here, but just quick review. Satoshi, one of the first uses of Bitcoin, non-monetary, he put a message, which became a meme, into the Genesis block. And if you think about it, that's very similar to writing something on the back of a coin on the flip side. The Romans did this. They changed their flip sides. So the Romans did not have internet. Shocking. But they had a very vast monetary network. And they used this to propagate their own memes. You might say propaganda, but it's essentially memes. And they would change the backs. Here's that we conquered the Gauls. Here's one, the empress is a goddess and is pregnant now. And they did this to propagate messages throughout their empire. And today, we have the power to do that permissionlessly. Anyone can mint on Bitcoin and propagate their meme through the network. Of course, it's not as easy through a centralized empire as them, but you still have that power now. Here's some of my fine artwork that I would like to just shill in the middle of my presentation, because why not? And this is some of my new creations, ugly lines, get it while it's hot. There's also other non-monetary uses, DAOs, the governance is not that bad. Layer 2s, all the people say do all the bullshit on layer 2, but that anchors back on Bitcoin. So essentially, all the weird shit you do on layer 2 is on layer 1 too. Ha ha ha, gotcha. Timestamps, about as exciting as this slide, but often non-monetary. Do sats exist or don't? We just asked everyone. Maybe all of your rage tweeting is a psyop. This is what Bitcoin Puritan life looks like. This is what non-monetary use looks like. And this is what some monetary use looks like, but I think this is what the conference looked like yesterday. And Andreas agrees with me. If I find a singular quote of somebody and put it in a presentation totally isolated of context, that means he must agree with me. And here we are today. Thank you so much. I'm Theo Goodman. I'm done. Okay.
I don't think you're done because we
with questions?
We can get questions.
Of course.
We also
of
have
course.
a panel after this, and it's
yes.
about non-monetary use cases. And
Great.
It's called proof of utility. So we do have a question.
Yes.
Please hold the microphone so that the people listening on live stream can hear this.
Thank you. Great talk. Thank you so much. I just have
Yeah.
I just have one question about the lines. What are the lines?
Huh? The
Ugly
lines.
I mean,
So-
they're really ugly. They're doing their job.
Each line, so the creative rule for the ugly lines is each line is made in one motion, and so there's no editing. It's one stream of thought. Each line is one pure stream of thought, and if you really look at them, then you will get an emotional reaction. Some people will react differently. It's almost like the modern form of Chinese calligraphy without a language.
Almost.
Yes, almost. Any other questions? Yes, sir.
Where can we purchase
Wait.
Okay, great.
Where can we purchase your fine?
So so he asked where can he purchase. Mostly I've done work on Bitcoin, on Counterparty. But to be honest, guess what? I minted these 3 on Ethereum because when I made them, I thought, what's the most hated blockchain at this moment? Then it really suits. So I did an edition of 101 of ones of these on Ethereum because at that moment, not even the art people liked Ethereum. And I thought, that's great. It kind of fits to the whole concept. Let's do it on fucking Ethereum. Yes?
Can I pay in Dogecoin?
Can you pay in Dogecoin? Yeah, if you DM me, we can do a trustful swap. Yes. Any other questions? Could be any range.
You didn't give your thought on do sats exist?
Oh, I mean, that's a good question. I think they have to exist, even if you say they don't exist. They kind of they exist. Does that make sense? How do you stack sats and then stats don't exist for other things? I think that kind of sums it up. I think the counter questions raise good points, you know? I think it's a matter of, but do they exist as like first in, first out? You know, they don't really exist like that. Yeah. As you can see, people have a lot of opinions about it, and that's great. Okay, what did you say?
Well, so just because I didn't have context, my hotel had 2 of the 3 elevators broken, so it took 2 hours
Okay. Yeah.
I mean, if the dust limit was lowered to 1 Satoshi, would that change people's thoughts around it? No. No?
No? Okay, they still don't exist for him. Yeah.
The code does not have any discrete object instantiated as a Satoshi. It has transaction outputs which have a value of Satoshi. Satoshis are an emergent property of the code. Yeah. Right?
Yeah.
In comments, there is.
I don't think anyone. Yeah. So I don't think anyone is arguing that you need a lens to like view these things. You know, it's a matter of interpreting the. It's a matter of interpreting the transactions.
It is a matter of interpreting because, like, on second layer protocols like Lightning, there are millisats.
Oh yeah.
Do millisats exist?
That's a good question. I like that.
Further down the rabbit hole.
Yeah. Do millisats exist? That's a good question. Yeah. What comes after that?
They only come in groups of 1,000.
Oh, really? Okay. Yeah.
Millisats, right?
Cool. Any other questions? Any other questions? Maybe we look at these really fine slides again. Is this how your everyday life looks like when you open your computer? I hope not. No. Does your life look like this?
What about the Supra, Theo? You put the Lambo, but what about the Supra?
I mean, that's your meme, the Supra. I mean, you know, maybe if you shill enough Satoshis that don't exist, you can get a Supra, you know?
With a really big wing, right?
With a really big wing, of course. Yeah, it could be. Is this what your conference looks like?
Do you think the NFT market is going to come back?
I think it's still there. It's just a matter of the perception that it's like not there anymore. You know what I mean? So I think without doing scientific research, just my observations, what we've seen during the whole bear market is still a lot of interest in creators coming to the NFT market. You know, so you saw the same or more interest, or maybe let's just say like realistic. You still saw interest in artists, creators, whether that be in the gaming or art world or other things, joining, making these things. And so my hypothesis on that too, why it's good, is because as far as like Bitcoin is concerned, I mean, people that are interested in sound money, economists, traders, BlackRock, whatever, you know, any kind of traders, dark market people, hardcore ideological libertarians, they're already interested in Bitcoin. Yeah? We kind of sold them on a lot of these concepts already. People that don't understand economics, people that don't understand sound money, people that have never bought a gold coin or a silver coin, but they like to collect Pokemon, but they will like pay a lot for a painting. People that like value that's a different value system. And so what we're doing is we're attracting a completely different value system into the ecosystem. And yeah, you're going to have some like clashes of like discussions of value, but I think that's why it's really healthy, because we have a completely different value system of people coming in. And hopefully they'll get intermingled with like cypherpunk ideals and all of these other good things. So you have like a very interesting mix of people. That's my hypothesis.
What is an NFT?
What
is an NFT?
I think it's a horrible, I mean, that word came from an acronym that means like one specific thing. I think a artistic token is pretty broad.
It's interesting. Like, I view NFTs, and it doesn't necessarily just mean art, right? But
Sure.
I view it as ownership of provenance.
Yeah, it's that too.
Because you know, that's the whole thing. Like, you can't own the JPEG, right? But you can own the provenance.
Sure. So most of the time, the artwork doesn't move when you send a transaction. And so the thing is just pointed to. And so it gets a little complicated with the on-chain art. Sometimes it kind of moves. Most of the time, it's just there. So that's true as far as your. So it's kind of like a cave painting. And then you have this like thing, this like unique drawing tool that proves that it was only drawn by that. And you're like sharing that, moving that around kind of, you know.
The art gallery, right? And it says donated by this rich person, right?
Yeah.
Basically donate so that other people can see their name on it.
But NFT,
Yeah.
in my perspective, it's only a way to
same way, we can sign message on Bitcoin, on Dogecoin, and say that digital thing was not changed along the way. And we can also say it's ours. So it's not signing something.
Just a hash.
Yes, yes, simply that.
Yeah, I think that's part of it. I mean,
But the number can have meaning too.
it's a little tricky to say it's the first, but it can be like the first one that minted it. Doesn't mean I'm the first one that had that idea.
The same,
but
because there are
yeah.
timestamps.
Yeah, yeah, sure.
Message, there is a timestamp.
No, I know. I mean, I could like front run your
Who's keeping
timestamp or
track of-
something,
yeah.
you know.
The
But
mempool.
but in general, yeah, that's part of it. All of those things are true at the same time. You know, it's a little bit of you're getting into a little bit of weird interpretations. But yeah. Any other questions before we start our panel?
Is it our responsibility to bring in the JPEG people into our values?
It's nobody's. There's no
Probably
like
not.
central responsibility coordinator. You know what I mean? There's no central responsibility coordinator. It just kind of happened, and that's what I think the whole time. That's what I've been saying the whole time. I think that's really good. I think it's healthy to have other things. I think it makes like events like this more interesting. And I think it's good to have like a discussion with different people. Not everyone is agreeing. You know, you have like a totally different value system, people that don't get a lot of these things. And yes, sir.
It's so much a complicated question for the time we have left, but something that I've always wondered about is the much more likely use case, at least from my perspective, for NFTs has always been kind of DRM, in the sense of DRM, verifying rights for many people instead of issuing one-of-one tokens, essentially. And I'm just wondering what do you think is the difference there between the kind of really large prevalence of one-of-one tokens versus the much more kind of natural, normally, perspective of making broader rights management with that?
Okay, so you have like that's a lot. You have one-of-ones. He's talking about, so those are tokens that are just one, and then there are additions, we say. So like a 100 edition of something. I think DRM is, so digital, I think it's tricky to enforce these rights with a bearer asset system. Does that make sense to you? Because who's going to enforce because in the end, so basically let's just like go to a discussion that happens right now. You have so-called royalties on some NFTs, and this is mostly in the Ethereum world or other EVM chains where you can program that into the smart contract. So every time it's sold on a marketplace, which is a kind of smart contract, that marketplace says every sale of this, 5% of that sale automatically shoots out to the originator address regardless, okay? But if I choose to find another smart contract, decentralized exchange that doesn't have that enforced, I can still do the transaction, and then they don't get anything. You see what I mean? And so that's why I think that a lot of these are at odds with the whole concept of bearer asset, where if I have it, I own it. You see so it's kind of a conundrum. I don't think there's an easy answer. I think that it's something that's been being experimented with. But I think that in the end, what I see happening is people basically build little walled gardens of permissions in order to facilitate these kind of royalty systems. So it's like you have the bearer asset asterisk, but you can only interact with the following smart contracts. And it becomes this never-ending cat and mouse list of things that you can interact with. You know, that's what I see happening. So it's kind of a tough one.
I mean, that's true.
Yeah.
Perfect description of
Yeah.
one of my criticisms of that, or one of
Yeah.
that. My perspective was more, obviously, you could use this more in the sense that, for example, TPAS is essentially using blockchain to do verification of encryption with our encryption network, Webs of Trust, and basically just use your program to verify hashes, to verify identity, etc., something like that. But no.
Well, I mean, that's cool too. I mean, I don't know exactly what KeyPass is doing. I mean, that's like a whole nother non-monetary use case of like zero knowledge proofs to like, you know, say, hey, you paid, but I don't know who the fuck you are, essentially. You know, that's really cool. Okay, I think I talked a lot. I'm going to talk more on the panel as we're starting without any break.
If you want to get a drink, you can go grab one fast, and then let's come back in 3 minutes.
Okay, cool. Thank you so much. Thank you, everybody. Jesus Christ. Cool. Let's get a drink.
Hey, I'm Vlad.
Get to do what I need to do. Missing you just ain't no good. Time, slips my mind. Slips my mind when I think of you. Time. This time won't change things. Ta-da-da-da. If there was ever a moment I'd like to box up time, it was that moment, that day. Seconds to minutes, time, minutes to hours, hours to days, you, days into weeks, into months, too long.
Sam Borgi. I'm the senior news editor with Cointelegraph, and we're going to have a really exciting panel here, hopefully, on the utility or use cases of actual proof-of-work networks. Oh, I see. We're about 45 seconds in. Okay.
Okay, yeah.
Got 40 seconds. Okay.
Cool.
Guess we'll wait.
Really pro broadcasting like equipment. That's really,
yeah, it is really.
Very impressed.
I like how we still get to look at that slide.
Yeah, poor Pepe's Lambo is
Pretty
a
good, huh?
masterpiece.
Yeah.
Masterpiece.
Make us laugh.
That's what attracted me to walk in the door, I have to be honest.
Yeah, gotta have good slides. I guess we're live.
There we go. We're live. Excellent. Okay. So as I was saying, hi everyone. I think that Theo provided a really good breakdown of the non-monetary proposition of proof-of-work networks. So I just wanted to kind of delve into some of the actual real-world use cases of proof-of-work networks. So I just wanted to kind of get everyone's sense here. What is the most promising use case that you think for building on top of Bitcoin or other proof-of-work networks? We can start with whoever.
Verifying zero-knowledge proofs, right?
Yeah.
And generally ordering things, right? But specifically with zero-knowledge proofs, like you can order a series of proofs that prove like incremental like state transitions. Mm-hmm. So if I prove the state goes from A to B in one proof, then in my next proof, I'm gonna prove that it goes from B to C. And then the proof of work network can like establish a canonical chain that like links all of those proofs together. So we can like have any application really like be ordered and secured by Bitcoin without Bitcoin having to like know about what that application is. So I think ZKPs are really cool for proof of work chains.
Yeah. Anyone else?
So your question was specifically about why proof of work networks are good for storing this sort of data.
Yeah, any kind of utility really, that best use cases.
The advantage in proof of work, or the disadvantages some people present it, is that you actually have an expense. You consume electricity for the purpose of generating new blocks. So whatever you put in there requires more effort and therefore is deemed as more valuable. And I know this is the Marxist, what's it called? The labor theory, labor value theory. Yeah. And it doesn't always make sense, but if there's a market for it, it makes a lot more sense than something which is proof of stake and the blocks are generated by virtue of just a bunch of people locking their coins and running Raspberry Pis.
Cool. So Carter, I know that QED has developed a lot of scaling solutions for Bitcoin and also on Doge now.
Yeah.
Can you kind of walk through what made you decide to expand support for Doge and why that's important?
Well, okay, so first of all, I came from the proof of stake world. I can attest that we weren't running our nodes on Raspberry Pis, but some exchanges sometimes would run nodes that were on similar type devices, like a 2 vCPU AWS instance. But yeah, so like I think Doge is particularly very interesting just because Litecoin secures it, or Litecoin and a range of other chains that can be used with Oxpo, but primarily Litecoin. And Litecoin is one of the few remaining secure blockchains along with Bitcoin. So yeah, I saw all of the pitfalls of the proof of stake chains, and I'm convinced that Litecoin and Bitcoin are the sort of two remaining bastions of hope that can save us from just all becoming POS. And yeah, that's why I wanted to work on Dogecoin and Bitcoin.
And what about the consortium that you guys have developed? Can you talk more about that and what you're doing there?
Sure. So basically, one of the great things that proof of work chains can do is just ordering things. So we have L2O consortium, which is just standards for like ZKP ordinals. And essentially what the ordinals indexer does is it verifies like a sequence of proofs and verifies them against a predefined like verifier key that anyone can deploy. So I can deploy an L2O application, and then I can post proofs that show like the state legally changing from one state root to another. And yeah, it's just like a very easy way to make verifiable applications that are essentially sequenced and verified on Bitcoin. Like L2O itself doesn't give you a trustless bridge though, of course, because we don't have recursive covenants on Bitcoin. But you can, in the same way that ordinals are secured and guaranteed by Bitcoin, you can build other applications that are, have those same security properties in that like you can know the exact state of the application by playing the blocks back from Genesis while running the ordinals indexer.
Yeah, Theo, I know you talked about the people who are into Bitcoin for the ideological reasons already there.
Yeah.
What role do you think ordinals will have to play, or any kind of NFTs on Bitcoin to actually attract more usability?
I think it definitely attracts people. It already attracted a lot of people from other chains, like Ethereum, for example, or other ones. Because I think that artists and creators, they're less ideological. They'll just go where liquidity is. And so they'll say, hey, if ordinals is a hot thing, let me try to use that. And then they're going to be using Bitcoin. And maybe they get infected by some ideological, rubs off on them that it maybe didn't exist in the ecosystems where they already existed. So I think that's really cool. And I also have been using Doge since something called Doge Party, which is counterparty on Doge. And it exists since 2014. And so we've been doing weird tokens and weird experimental NFTs there. But I think that, I think ordinals definitely and counterparty definitely have attracted different people to the ecosystem.
Yeah. Anyone else want to add anything about the growth through NFTs? Anything else?
I can say that in my perspective, NFTs, ordinals, doginals, whatever, in the current protocol on Bitcoin or Dogecoin, it damages because if you want to use as a currency and the use case is for ordinals or doginals, it makes the fees go up and the size of the blockchain grows exponentially. We see, for example, since last year, it grow up in size almost double. So in current protocol, I don't see any real utility and use case because it destroys the creation. Of course, initially in 2013 was a joke, but we actually want to create a currency, and for that to happen, doginals or ordinals is not the way.
Yeah, Theo, I know you've been writing about NFTs now for a long time, like before NFT was actually a thing in the mainstream. So I think I saw one of your Medium posts from like 2017 or 2016, something ridiculous like that. How can you kind of map the evolution or the growth of the NFT market? Has it taken you by surprise? Just kind of walk me through your initial perceptions of the NFT market and how it's grown over the past market cycle or two.
I think because I wrote some of those articles, and I by no means was one of, like, there were other people doing stuff back then too, for sure. But sometimes when I see some of the things in the NFT world, I call it the Frankenstein effect. I don't know if you know the story of Frankenstein, but the doctor like started making this monster, and then the monster like started doing all this crazy stuff, and you're like, what the fuck did I create? So sometimes I feel like that. Yeah, it's more than I thought. It's definitely caught on more than I thought. On the other hand, I think during Rare Pepe, when that started, so that started in September 2016, and I remember the excitement people had when they were able to sell one of the Rare Pepes for like $5 or $10. People went insane. Of course, you have to think 2016, the amount of people also just in Bitcoin was dynamically lower, or in crypto too. So now that's dynamically higher, and now also the NFTs have gone dynamically higher too. So I think that in some ways I'm surprised, in another way I'm not, because I think there's a stronger emotional reaction to these things. And also you have to think, so Bitcoin is mined by the network, and so there's kind of a disassociation between owning a Bitcoin, whereas if I make a creation, it's very personalized, and I sell this creation, that's like me. So that's a very unique proposition as opposed to that. So it has a very strong emotional connection. That's why it blows up so much.
And are there any trends that you're looking for in this next market cycle with NFTs? Any networks, any kind of artworks, or do you just think the market is still ripe for innovation with the current artists?
There's definitely a lot of technical innovation still going on. I think Ordinals is doing a lot of atomic swaps. I mean, it's just showing you like what's possible. It's crazy, like the stuff that those guys created. You know, they have these dexes that operate on atomic swaps, permissionless. Probably a lot of the people mostly doing active daily Bitcoin things in a permissionless way are probably ordinal people, which is kind of crazy if you think about it, you know? So think of it what you want. That's true. And it's definitely like stress testing the network. You know, if we want, so if you have like the hardcore currency argument, yeah, we want people to use Bitcoin to pay coffee. What if 1 billion people started using Bitcoin for coffee? It would be, you'd have a similar network effect. So this is a good test in some ways of what's going on. Also, as far as like you were saying with the Doge and the problem with doginals, and there are also the motivation from the large majority of ordinals enjoyers, Bitcoin stampers, counterpart people, is also to try to make a way to make the transaction smaller too. And there are like technical innovations being made to lower it too. Okay, it's still not going to be lower, but they want it lower too for what they're doing.
Do we need to inscribe like the image or just like the ownership of the image? Like that's a
never-ending question.
Like is a proof of work blockchain a good place for your data availability? Right.
I totally agree.
This is kind of a tough one. Right.
It's a tough one, yeah.
For a layer 2, yes. For example,
not for a Validium, right? But
yeah, because if we are increasing the database where you store all transactions and is publicly available and shared between all nodes worldwide, we see the huge usage of data that is useless.
So we just need to make the incentives such that like. Because we can't say, who are we to tell people what to inscribe on Bitcoin, right? So we just need to make the incentive such that the spam is, it's very expensive to propagate, right?
Yeah, okay,
this
there's
is the way to handle things.
you have to make it, so basically it's the argument of versus on-chain art. So that's the meme, that's the value proposition, and people really like that. That's why the order, because that is, it's offering you permanence of data storage.
Maybe we
and
can
the
inscribe
argument,
some GLSL shaders or something.
I totally, I've had this, just, you know, that's what people are marketing it as.
Sure.
And it's kind of true. It's like, hey, I want my art to be the most permanent ever. Where am I going to put it? I'm going to put it on Bitcoin, or I'm even going to put it on Doge. You know, and that's the selling point. But so if you want people,
the more people that do it, the less likely it is to come to pass.
The
there's
problem
a
is
few-
the full node doesn't have the choice
Exactly.
of to choose what data to store.
well, they do. They can prune. So it's like that's the whole thing. There's
No, it's not a full node. If you prune, it's not a full node.
well, depends on what. Okay, what do you call a full node? That they
a
have
full
every.
node, they have all data. If, for example, if I start a node,
I don't know about that.
If everyone from the
That's
node,
kind of a hard. I
It's time for zero-knowledge proofs. Let's just prove from
Index.
Genesis, and then
Yes, to
we
track
can
authorization.
do everything.
So I think so.
And
Without
then we
getting,
can prune and still know.
I'll probably say something wrong, but I mean, you can still have like enough. You can still prune and be a full node. That's what I would say. A full validation. Yes, exactly.
So I still play back from Genesis, right? I just erase the evidence.
of all transactions.
So you have.
Well, other people, I can't do it again without downloading more data, right? But
So
assuming there wasn't a cosmic ray, right? We should.
So there's something called Bitcoin stamps, and they're so-called unprunable because of the way that they. But that's like a debate upon itself. And then ordinals people said, no, that you can prune us. That's a feature, not a bug. So you have like a ongoing people spinning around. But what's really cool is people are trying to figure out all this shit that we usually normally don't talk about that much. You know, we're not. You know, before it became an issue, it was made an issue. Then we were like, okay, well, what is a full node? Do I need to run a full node? You'll have more people in ordinals or art communities running full nodes because of this. You know, experimenting. So I don't even know what the question was exactly, but yeah, what was the question?
Well, I think we strayed from that a long time ago.
Yeah.
I think you were responding to one of his questions,
I think that
right?
you can prune and be a full node.
Yeah.
But we all agree that the harder it is to run a Bitcoin full node, the fewer Bitcoin full nodes there will be, and potentially the less secure the network.
That's an interesting
There's
proposition.
There's some relationship there.
Could be. I'm not sure if that's actually what's happened, though. I mean, it would seem.
I think
right?
the only reason why I've spun up multiple Bitcoin full nodes in recent days was because of ordinals indexers, by the way. So I'm kind of I'm a pro ordinals person.
Yeah.
But I definitely think there's something to be said about if it gets too unwieldy, maybe there will be actual limitations.
Do you actually need to store the image? Don't you need only verification that the image is
It's maybe
the
that should exist
original?
on IPFS, and we should store the hash on Bitcoin.
No, I'm
right?
not. I'm not totally against it. I've made lots of things like that,
For sure.
like in a similar way. I think
This
so.
is the
Basically,
Ethereum way of doing
so
it,
basically,
right? Oh, sorry.
essentially, yeah. So basically, you just have to make it cool to use L2 or some other interesting storage mechanism for the NFTs. Right now, it's not cool.
I got to build a narrative around it.
So you have
You
to
can
build a
you
narrative
can
around
build
it to make
on
it
those
cool to store the images on. I mean, there's this thing Arrowweave, but that's weird too. Or if it's stored on Rootstock, or I don't know where you want to store it. You know, but it has to be somehow cool, and it has to be some proposition of permanence of a similar value as one of the proof of work networks.
Yeah.
Well, we've mentioned use as a currency a few times now, and the economist in me really wants to talk about that a little bit more. How far away do you guys think we are in terms of whether it's using Bitcoin as an actual currency or Doge? I say this because I know El Salvador has launched a big initiative, and I think they recently admitted that, Bitcoin uptake as a payment system hasn't really caught on. How far away do you guys think we are to actually using Doge as a currency, Bitcoin as a currency. I know there's a lot of tax implications to that as well, but kind of walk me through your thoughts on that.
I think there is a long path away because the government still don't accept as an exchange currency. If they start to accept as a currency that we can, for example, pay taxes directly in cryptocurrency, in Doge or Bitcoin, yes, there will be global adoption. Until then, I don't believe it. I only believe that people will experiment, accept, for example, tips. In our case, we are trying to make people to start accepting tips in Doge, not accepting and selling things in Doge, because even in Bitcoin, I don't think it makes sense for now, because it's really difficult, because everyone have to exchange for fiat money, and they have to declare and pay taxes. So I see a long path away.
Doesn't the state of Louisiana accept Bitcoin for payment for government services? Wasn't there like a big...
Because that's why Bitcoin was invented, right? To pay taxes.
Yeah, exactly.
That's exactly. Yeah, I totally agree.
I love it.
Yeah, I mean, I'm not. Like I said
It's a
earlier,
little
I kind of
weird.
think that people like really appealing to the nation state things are like the same people that go to a strip club and think that a stripper is in love with them. They're like, yeah, but Angel loves me.
She pretty...
But like, yeah, but like the question is, will it be used as a currency? It needs to be in the parallel society used as a currency first. Because if it's so cool, then it's so cool that the government is forced to adapt it. And like maybe in the case of El Salvador or other currencies, I mean, they're like a challenge to the dollar. So it's like, okay, we want to have something separate from the dollar. That's a clear reason to do it. And the other clear reason is there's so much of a parallel society using it that we're forced to use it as well, as far as like nation states using. So basically, if you want to get it used, we have to have something cool enough to use it for, whether that's JPEGs, whether that's drugs, whether that's really cool services that you only accept that for.
Yeah. And do you think? Yeah, go ahead.
So when you ask the question, how far are we from mass adoption? You're just triggering the individual within myself, and I'm asking myself, how many times have I actually used this for payment? Because if we're not starting the economy ourselves and we're not using it for payments, and we're holding speculatively, assuming that others will build this medium of exchange function, we're not going anywhere.
Yeah.
We're just hoarding our little Pokemon cards, which are digital.
Yeah.
Because honestly, we don't have much privacy either.
And no one have tools to easily accept payments in Doge or in Bitcoin.
You can fork BTC Pay.
For example, I have a store. How can I start accepting Bitcoin right now?
Like Square?
No.
I have to contact a third party?
Yeah.
No.
Yeah.
You can use BTC Pay, you can use LMBits.
Is it easy to use? Can I plug in and that's it? It's easy as it?
And I'm sure, like,
I
most
try it.
CMSs have integrations for some kind of like Bitcoin payment gateway, right? There's like, this exists. It takes a while to get finality, right?
Yeah.
And
The
you
learning
have to
curve
use
is really
Lightning,
big.
And then,
What if we can just plug a simple box and start accepting payments? This is what we in the Dogecoin Foundation are doing.
Yeah.
We are building a software that anyone can build in their own hardware and can plug in, and a simple click, start running a node, accepting payments without any knowledge in every language.
Yeah. Well, as Vlad mentioned, we're kind of in a speculative phase right now where we're sitting back waiting for someone to build that system. What do you think about the growth of the ETF world then? Like, that's basically continuing to monetize and financialize Bitcoin as an asset as opposed to, or can it be both, right? But right now it seems like it's going definitely in one way. And as you mentioned, at the Bitcoin Nashville conference, which I was there, was absolutely nuts. People, as you mentioned, jizzing in their pants over Donald Trump, which is an absolutely...
The Nashville one, right?
Yeah,
I
it was
there too.
absolutely wild to see that. It's, it's clearly a transactional thing for him. He doesn't care about Bitcoin or doesn't care about...
I have to admit that my pants got a little bit...
Yeah, I mean, you think about your bags and the fact that my bags are going to pump out the BlackRock buying dip, right? But do you think, like, is this... I mean, what are your thoughts on Bitcoin becoming increasingly financialized in this way, and does that kind of lend to actually building up this?
Both sides need each other.
Yeah.
You know what I mean? I mean, like, need is maybe not the right word, but I mean, you can't stop it.
Yeah.
So okay, you have the ETF people here, and if you think that's not good, well then make something really cool that is not that.
Yeah.
that's what do you want to do? You want to like break their windows and be like, no, you can't have Bitcoin? I mean,
Scrub the ETF from the
what are you
earth.
going to do? I mean, you could voice your concerns. You can build businesses and make Pepes or whatever it is you think that is not that use case, and do it. I think markets will find a way to make money where there's a way to make money. And that's. We should be clear. That's what they're driven. They're not ideologically driven. That's clearly,
Bitcoin isn't a really good way to pay for coffee, though.
On the other hand,
There's
the
actually
benefit,
fees are really high.
the plus of the ETF people is that maybe there is some intermingling of ideology. Maybe they do stumble across like, hey, what is this Bitcoin thing? Why are people so interested in it? It's not a stock. It's not a bond. It's not real estate. Because they're looking at it from asset, and there's going to be a percentage of people that do get like the ideological bug, whatever variation of that, or maybe they get into NFTs. Who knows? So I think we do have that effect some, but that's the positive effect of it, I think.
Excellent. Well, I think we have less than 5 minutes left, so I think we'll just open the floor to any questions, comments.
Oh, here we go.
Go. Jameson.
I'm interested to know if you believe that ordinals, non-monetary uses of Bitcoin, whatever they may be, have effectively raised the floor on the block space market such that we will never see empty blocks again.
Well, I mean, the amount of transactions in a block depends on the miner. And so, like we've seen in the past, I will mine an empty block because that's the right given to me by the Bitcoin protocol. So it really just depends on, that's one as far as empty blocks.
So Ocean maybe will have some empty blocks.
Yeah.
I'm monitoring the blockchain.
From time to time.
And 1 megabit limit on the Dogecoin. Not always have full blocks. Only when there is hype, full blocks starts to increase, but we can see it that in the last year, yes, increased a lot, full blocks.
I think probably you're right, probably won't see empty blocks.
Another way of saying it is we'll never see an empty mempool.
Yeah, exactly. Yeah, I know what you meant. But I think probably not, because there's so many people interested. I think, so this summer we saw pretty low fees, maybe you guys noticed. And there was not a lot of ordinal activity. You see that sometimes in the summer, but I think now they're up a little bit. But it still was not completely empty. There was always a backlog, yeah.
When was the last empty block that wasn't due to like filtering?
It's been a while, maybe even over a year.
Yeah, that's pretty cool.
Depends on, yeah.
Yeah. Go ahead. Yeah, go ahead. Yep.
You said earlier that basically make it cool where to store the art. And I'm just wondering, and that's kind of a prevalent idea in a lot of cryptocurrency spaces, but I'm kind of thinking, isn't that putting basically putting it the wrong way around? Because as just the general user, not something in any way interested in cryptocurrency, why would I care where it's stored? I care about the ultimate functionality that I derive from it. So isn't that actually the more important question? And shouldn't that be driving how we store it and how we build these things?
But it's just cool, right?
So basically, the novel,
it's not doing any utility anyways, right?
So I just responded to a tweet the other day. The guy said, "My ultimate ordinal, on-chain, so many recursive mine ordinal. What do you call it? Satoshi, so and so, special Satoshi, so and so." And I said, "Oh, because I guess it's about the art." Because he just named 10 technical things. I was like, we don't even know what it looks like. You don't care. It's just collector, jibber jabber, technical blah blah. You see what I mean? So that would appeal to some. And some people, like you said, they might not give a shit about oh, what Satoshi is it minted on, whatever. They just care how it looks. They don't even give a shit where it's stored. So I'll tell you a really fun story. Rare Pepe Nakamoto card. So it points to a image somewhere in the web. The web link is broken. Okay? Yeah. and it's recently been sold for over $200,000 with this broken web link. People don't give a
Lol.
shit because there's a consensus of what this thing is.
That's so cool.
Yeah,
Can I-
yeah.
I agree
Yeah.
with you on, but that's again, this is still kind of within the bubble. Like when I was 16, I was happy to do 24 hours emerge -e world for Gentoo and install Gentoo, which is Linux distribution, which just was the most nerdiest thing you could do, like in the early 2000s. And but that's still within our bubble where these people agree. If you were to go to sell to an art gallery or someone, they wouldn't. Act like that.
So what the okay?
There
so,
was an auction though, right?
So
For, like
there-
some NFTs,
so
on,
there's-
like Christie's
so
or
there's-
Sotheby's or something.
Exactly. There's definitely is big action in Sotheby's and all of the big art houses. And they're more like on the art side, less of the collectible, but they still have some of that too. So again, to be honest, it's just narrative. Okay, so they get someone that comes in there and it's like, yeah, on-chain art is the cool thing. They'll be doing on-chain.
Why don't
an
you use
on-chain
BFS
auction.
to start it?
Well, and then the other one, it's just like it doesn't matter about the technicals of the on-chain. It matters who the artist is. It just depends on that narrative. Why don't you use IPFS? Because it's not permanent. Because you have to.
The same with the blockchain. If, for example, all nodes disconnect at the same time, or there is no internet.
I mean, it's
how
just
you
about.
can-
But it's
just the likelihood.
degrees, right?
It's just
Yeah,
the likelihood.
degrees.
It's just the likelihood, and it's just a to be honest, it's part of a marketing narrative. You have to say, "Hey, it's on Bitcoin. It's permanent forever." That's what people say. Well, we don't know that, but that's what they say. You know,
As long as Bitcoin doesn't die, though, we're probably
basically
gonna,
you're betting on that, and they don't know about the availability of that image because right now they're not parsing it from a node; they're parsing it from some web thing. You know what I mean? Like none of these ordinal explorers are actually getting the image from the node. They just have a web image of it. That
Why don't they have
parsing,
only
you
the
know?
hash and don't care about the original asset?
Hey,
well, so
make it
we
cool.
did make it
You know?
a fun explorer that actually hits like I think it's like the Electors API, so you can
I'll-
inscribe purely using like these like full history node
I think-
APIs and then view it as such. It takes too long.
I
though,
think
right?
one
You need to cap it.
observation is because it's a standard thing in marketing. If you piss off a lot of people, then you get a lot of traction. You know, and it's just a thing we have to deal with somehow as humans.
Yeah.
You know, it's part of the whole thing.
Yeah. On that note, we're out of time. Thanks, everyone. Appreciate it. Thank you.
Thank you. Okay. Thank you.
Thanks, Simon.
Thank you.
Because now is your time to glow, your time to grow, your time to twinkle and sparkle for the whole wide world to see. Find your light. Find your light. It's there. Find your light. 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 If you Wave a little light of love so I can get to you. Open up your heart and soul so I can see through you. So I can get to you. Open up your heart and soul so I can see through you. I can see through you. Yeah. Give a little light of love so I can get to you. So I can get to you. See a little light of love. Open up your heart and soul so I can see through you. I can see you. I can get to you. Leave a little light of love. Open up your heart so I can get to you. And soul. Open up your heart and soul so I can see through you. Little light of love, of so I can get to you. Open up your heart and soul so I can see through you. I can get to you. I can get to you. Give a little light of love so I can get to you. Your soul, your soul. Oh yes. Open up your heart and soul so I can see through you. Little light, little light, little light of love. Leave a little light of love so I can get to you. Of love, your love. Ooh. Open up your heart and soul so I can see through you.
Probably.
I went to that restaurant. They took 30 minutes to give me a salad.
Oh, okay. Sorry. Yeah, we can open the door. Hello, hello. Welcome back. I am excited to announce David Burkett. He will be giving a talk on privacy and how, some of us are using privacy technologies and we get given this false sense of security that we are safe, but this can be a misassumption. So David is going to dive a little bit into that, and he's a developer at the LTCFoundation. So please, let's put your hands together for David.
Thank you. Wow, it is packed in here. I'm glad to see the crowd. This is great. Yeah, we got a line out the door for those who can't see online. This place is really happening. So for the three of you here, raise your hand if you use a VPN when browsing the internet. Okay. Keep your hand up if you know what a VPN kill switch does. Okay, all right. So a kill switch is like an emergency brake. If your VPN connection drops, the kill switch immediately cuts off your internet so you don't leak your real IP address. And this tiny bit of info might have been able to help save the main character in our first case study. So a few years back, there was a big Ubiquity hack. There was a data breach, lots of information leaked. There's this guy, Nicholas Sharp, he was a senior developer at Ubiquity, and he, like many insiders, had access to a lot of sensitive data, and he wasn't happy with just working at Ubiquity at the time. He wanted more, so one day he decided to take a massive risk. He used his insider knowledge to basically hack into Ubiquity's systems and steal a bunch of data, and it was no small amount of data, something like 100 gigs of confidential data, including customer information like names, social security numbers, that sort of thing, as well as a bunch of corporate secrets and everything else. And it was all taken with a clear intention, which is to extort the company. For this case, he tried to get 50 Bitcoin for the info, and they refused to pay, so he ended up leaking the data and massive breach, whatever else. But to cover his tracks, Sharp used a VPN service, thinking he could keep his identity hidden behind layers of encryption and secure IP masking. So, seems pretty clever, right? Use a VPN, they're not going to know who it is, but there was a small problem. Those VPN client had a kill switch, he never turned it on. So as I'm sure you can guess, Sharp's VPN did disconnect briefly, and it exposed his real IP address. Just that brief disconnection until it reconnected. He had been connected via ClearNet, no VPN or anything. So his real IP was leaked, and that was all it took for the FBI to pounce. They were able to quickly connect the dots. He was arrested. All his efforts to cover the tracks, extort money, whatever else, it all came crashing down because of that one little privacy failure. A failure that millions of people experience every day, often without even knowing it. So in a world where privacy can be compromised by the smallest detail, the importance of using every single proper safeguard is paramount. Sharp's story is a cautionary tale for anyone who thinks a little privacy is good enough. Like, you really do have to be perfect, because when it fails catastrophically. In the early days of Bitcoin, there were lots of technical-minded people talking about the privacy capabilities and limitations of Bitcoin. You can see even in the white paper. Satoshi briefly discusses the kind of information that is safe and is not safe. He mentions how some linking is still unavoidable. So linking multiple inputs together when you spend kind of tells you that it's the same owner, various things like that. There's ways that metadata is leaked about each transaction, even though they're pseudonymous. We had some more vocal people. Perry Metzger was well known on the the cryptography mailing list where Satoshi originally announced the paper. But you can see he says, Bitcoin transactions aren't anonymous and untraceable. If you don't know why, just learn how Bitcoin works, right? And then even Thamos was on the Bitcoin Talk forum very early on, discussing the many limitations, and that's actually a pretty good thread if you want to go try and find it. You can see how the early developers were thinking about privacy and anonymity with Bitcoin and its limitations. But of course, what does the media and all the users do with that? Well, they immediately start labeling it as anonymous. It's this new anonymous cryptocurrency, new anonymous payment method, perfectly anonymous, you're good to go, feel free to use it, whatever. So I know when I first learned about Bitcoin, started learning about Bitcoin, it was late 2011. And back then, most of us normies thought that it was pretty anonymous. That was just the claim at the time, and I took it at face value, as did many, many others. And because of that, many ended up taking excessive risks that they wouldn't otherwise even consider, such risks as buying drugs illegally online. And of course, that brings us to Silk Road. So Silk Road, I'm sure most of you have heard of. It was created by Ross Albright in his very early years, right? And he created the illegal marketplace. He used the alias Dread Pirate Roberts, and he was able to facilitate the purchase of drugs and whatever else, hacking services, some extremes such as hiring hitmen. Which I'm not sure that it was ever successful. I'm sure it wasn't, but it was all on there. I remember I had browsed it before, and it was all kinds of crazy stuff. Never bought anything, but I had browsed it, and it was a pretty crazy time. But he went to some lengths to try to preserve his privacy. He knew how dangerous what he was doing was, so he did everything he could to minimize, to maximize his anonymity. He only made the site accessible through Tor for dark web. He even routed his Bitcoin transactions through Tumblr, which was pretty uncommon early on. Tumblr is like a type of mixer, a swap service, something that's in earlier form. But despite all that, of course, he made a series of mistakes that ultimately led to his arrest and multiple life sentences. So I'm going to go through a list of some of the issues he had. So he had early advertisements. So in January 2011, he was using the name Altoid on forums like Bitcoin Talk and Shroomery, and he was trying to just promote, he's just promoting Silk Road, because there's no users when you just plop something onto the Tor network. There's no one coming to it, so he had to promote it. So he used these various pseudonyms, but one mistake he made there was he used Altoid, and he ended up reusing it somewhere else under his real name. So he had used it. I don't even remember where it was at, but there was. He ended up leaking his actual email, which was rossalbright@gmail.com. So that was one of the things that later led to his identification there. So he also registered a Stack Overflow account under his real name and asked a question about Tor, even posted a little snippet of code. And within a minute or two, he had realized how bad an idea it was, so he quickly changed his username to Frosty and his email and everything else. But by that time, it was too late. The internet is forever. And that's actually one of the other things that was used to tie him to DPR was a reuse of Frosty as a username. His computer name was Frosty. There were various other things. So lots of recurring things here. And then there was a major technical oversight, they had a CAPTCHA message on the login where you have to just prove you're not a bot, but it ended up being kind of leaky. It would make a request out to the internet over ClearNet, and it would actually reveal real IP, so you could use some timing analysis to kind of figure out which IPs are accessing it when. And that actually led directly to the discovery of the IP of the server it was hosted on. It was hosted in some server in Iceland, which they went and covertly copied. They left it running, but they copied the whole thing. And when looking through it, they were doing their normal analysis of it. They found a ton of unencrypted messages. All the private messages on the board and everything were all unencrypted, and you could see the communication between people. And they used that to compromise some of the other admins there, which then they used to kind of social engineer Ross and make his capture a little easier. And even during the trial, we found all kinds of other evidence was presented. Once they got his laptop, it was a gold mine. It was game over, because in there they were able to tie the timestamps of when he would log into Google with the times he would log into Silk Road. So basically, he would open his laptop, and everything would log in at once. And then when he would close it, it'd all log out. So all these timestamps just matched up. It was really easy to make a case at that point. And they even went through blockchain, the transaction history to prove, even though a tumbler was used, they were able to prove that, or at least show with a high probability that he was involved in each of these transactions that DPR was known to be involved with. So, despite his technical know-how, clearly he still made some mistakes, which many of us will make if we ever try to, when we're terrorists, fighting the government, we got to keep these in mind. And of course, by 2014, we had Chainalysis. The party had officially come to an end. For those of us who still thought Bitcoin was maybe private, that was no more. We could no longer pretend. Since then, Chainalysis has worked hand in hand with Satan to unwind long transaction graphs, to perform heuristics, do all kinds of fancy stuff to prop up government and big business, as we all know. So by this point, many of the early Bitcoin adopters who were claiming it was private were starting to regret some of their decisions. And over the years, Chainalysis has been used to prove certain actors were involved in hacks and purchase of drugs or various other things, all kinds of problems. So, there was a movement then sort of to move to more private coins. We had Monero coming then, and some of the others. And there were spin-offs of Silk Road. There was Silk Road 2, there was all kinds of others. And they tried to use the more private cryptocurrencies. But again and again, mistakes would be made. They'd be caught. They were all short-lived. There were always common themes. So lack of understanding or technical oversight. So the CAPTCHA leak or the lack of knowledge about VPN kill switches, all kinds of things throughout all these cases. You see the same recurring issues. You see hubris, just a blind confidence or blind faith or overconfidence in the technology, just a belief that, oh, I'm using privacy tech, I must be private. But there's so many things that can go wrong. It's just like security. You need everything to go right. If just one thing goes wrong, that's all it takes. That could be enough to fully compromise you. And then complacency or laziness, just reusing pseudonyms. for different purposes. While that maybe isn't enough to convict you, like anybody can go use my pseudonyms, whatever, that was all it took for the FBI to kind of be on Ross's trail, on his trail there. And from there, they gathered all kinds of evidence. So just simple little mistakes, laziness can lead to all kinds of issues. It can be the key to bringing down whatever crazy things you're doing. Let's just go with that. All right. And as you see, we're still making some of the same mistakes as the early Bitcoiners. I've developed code for both Grin and Litecoin, so I can make fun of them. But they're certainly by no means unique to these two coins here. You see, there's always going to be dedicated believers, or more often financially incentivized holders who will make any kind of crazy claims, whatever. Will always try to overstate the privacy of a cryptocurrency or a technology or whatever else. Like you can see that one over there. It's kind of funny because it's like, oh, get Bitcoin from a non-KYC exchange, CoinJoin, whatever, use Tor. But like, you still should use Tor with mweb. You still should use a non-KYC exchange. It's just a belief that like, you're using mweb, you're safe. But that's not necessarily it. You need to understand how mweb works, what it protects you from, what it doesn't. And this one here is from one of the big Grin developers when the first ever Grin transaction was created. He says, that's all the detail anyone's getting about that. Well, that's not true. It wasn't much longer that a paper came out that showed that, that certain leaks or links between transaction inputs and outputs could be found, which we even knew about. It's just kind of like the excitement took over, and so in reality, a million things can go wrong. I'm not going to go through all of these, but there's just the timing analysis we have seen. We've seen civil attacks, or I'm sure you guys have heard of. So these three here have to do with like the decoy-based systems, like Mimblewimble and like Monero. They have like these anonymity sets that come from like using other transactions along with yours to kind of like statistically or probabilistically like hide amongst others. So if you have 10 transactions that you could be a part of, as opposed to just one like Bitcoin where it's very clear which transactions, which whatever, you try to kind of hide there. But these different attacks will kind of unwind that, like a reuse of or even like a spending of coins, like a reuse of a service, say. So if you use like the same coffee shop every week, well, even if you're using Monero and you have plenty of decoys, you'll actually find that like they can kind of unwind some of those paths and find common inputs to all of them that will end up leaking some of identifying some of the inputs that are owned by you, even though theoretically it should be probabilistically hidden. But there's address reuse that we all know about. Wallet fingerprinting were common issues. Yeah, all kinds of things can go wrong. And even like things that aren't, this is all like chain related stuff, but there's off-chain things that can go wrong. There's like something as simple as like a turn of phrase you use or something. Like think of the attempts to identify who Satoshi was, right? They used stylometric analysis. They obsessed over the spacing between the words and things like that, and the number of characters per word on average, and all these different things can out you that you might not even think of, that even if you have perfect tech or perfect adherence to privacy tech, you can still be found out through other ways. And if you guys aren't familiar with Zach XPT, he's always helping out with new hacks to identify, like, to follow coins that are hacked. And it's impressive. He's he's a bit of a savant. He can follow coins through like Tornado. He can follow them across chains, through bridges, swaps. It's really impressive. And at the same time, it's really scary because it's like this one guy can do all this. What the hell are we even trying to do? Like we're never gonna hide from serious adversaries with lots of resources. So if you're feeling kind of paranoid, I think that's a good thing. That should be the takeaway here is privacy. Like it's super hard to achieve, at least from, depending on your adversary. If you're trying to hide from, your ex or a stalker or something, as long as they're not like Zach XPT or some crazy genius like that, you don't have to be quite as concerned. There's simple steps you can follow to minimize risk. But if you're trying to, for all of us in here, I assume we are involved in terrorist activity, right? So it's a little more difficult then to try to hide from massive governments like with limitless resources. But so you really need to know who it is you're trying to hide from, what it is, what kind of privacy you're trying to gain. You need to understand how privacy systems work. If you don't really, like even the use of VPN in the first place was a bad choice for the Ubiquity hack because like once they learn what VPN it's from, they can usually subpoena them to try to find who connected. It's more of a Tor thing or whatever else that you should be using. So really just understanding how privacy tech that you're using works is absolutely necessary. Keep identities separate. If you always post with Frosty, probably shouldn't also post with Frosty when you decide you're going to become a drug kingpin. That's just not good ideas. So always use single purpose NIMs. And then always use privacy tech. If you just connect to Tor, do your illegal thing, whatever, and disconnect, someone monitoring enough nodes can maybe piece together some timing to find out it's you who's, it's this IP that is connecting at this time. There's a process that involves handshakes, whatever else, to join the network. And if someone controls enough of the nodes, they can piece together info to determine that it's you connecting for this exact period of time that this business happens, and then you bail. You want to really always be using whatever privacy tech you use, or at least be using it as much as you can. Same goes for cryptocurrencies. Oops, shoot, what'd I do? Same goes for cryptocurrencies, like for mweb. You don't want to just peg in, send coins, peg out, because you peg in, you see the amount, you send it, whatever, but then you peg out, you see the same or similar amount, you gain nothing, right? You need to be keeping your transactions, you need to be keeping your coins on mweb, you need to be transacting on mweb with real life transactions to be able to make the most of it. You don't just go in there. It's not like you just, I need some privacy, let me just clean this. That's not how it works. You have to really stay in there. And when all else fails, use cash and speak in person. All right. Any questions?
But it's more for the audience so that they can hear. Thanks.
So if you were to create your own Silk Road website today, how would you do it?
I'm asking for a friend.
Is that friend the FBI? CIA? Well, for starters, Zach XPT will show you how to not get caught with on-chain mistakes. Satoshi Nakamoto would show you how to not leak your identity through the text and everything else that you leave. And when all else fails, I'd say make friends with North Korea.
Thank you very much.
You're welcome.
So what can we do to improve mweb's privacy?
Usage. So a small anonymity set is never going to protect anyone. If you are, I used the example recently of like, I'm in Germany here, and I was walking around in shorts, and everybody's staring at me like, who is this? What is this American casual BS here? I stuck out, right? It was very obvious, like, this is some dumb American here. And so what you really need is you need a crowd of similar transactions to gain anonymity from, to have a bigger anonymity set. So the more real-world usage we have on mweb, the better privacy. And as far as like individuals, how can they improve their usage of it? You have to learn how the tech works and use coin control and careful management of your individual coins, UTXOs.
One more question,
Yeah.
follow-up question. So are there any technical changes that could be made to improve the privacy of mweb?
To the protocol itself, there's nothing simple that comes to mind. There's lots of things we could do to get stronger privacy, but they come at very serious costs, especially scalability. But there's things that we are doing to like kind of like on top of it with the MixNet, mweb, or MWixNet, I don't know what we were calling it, but like the coin swap service. Yeah, that's the big one. The coin swap service would allow you to basically in the background submit coins to like a service that would mix them all together and give you fresh new coins. That's the big thing. Yeah.
I just realized that I have 16 seconds, so I'll be fast, even though it's a pretty extensive question. How would you describe the differences between Grin and mweb?
So Grin is a pure Mimblewimble implementation. It's very clean, very mathematical, very like scalable. mweb is it's like a heavily adapted version of it that comes with some trade-offs along scalability and even security in very obscure ways that are very unlikely to be impactful, but with the huge benefit of being able to send to offline addresses, to not have to actually communicate with the receiver, to send data back and forth to make a transaction. It works just like regular Bitcoin and Litecoin. Okay.
Perfect.
Thanks, everyone.
Thank you, David. Okay, we're gonna All right. Hello, hello, hello. I am pleased to have Kerry Washington joining us for this next talk. He's the general manager for Light Wallet at the Litecoin Foundation, which he's been working on since 2017. He's going to walk us through mweb for daily use, where mweb it allows a measure of privacy into transactions. So looking forward to hearing how that works.
Thank you so much. Thank you, thank you. By the way, if any of you think this is a talk about internet in Johannesburg in South Africa, that's the other room. This is mweb for privacy. So I don't know how many of you were actually at David's talk. This is really good. This is a white paper that we did about the first mweb mobile application. Right, just a little bit about me. Like she said, my name is Kerry Washington. I've been in the Litecoin Foundation for 7+ years. I've worked at a lot of startups, Apple, Mapbox, Ticketfly. I'm a retired U.S. Army signal officer, nerd squad. We make really good coffee. And I went to Santa Clara, which is in the heart of Silicon Valley. But my real passion is football or soccer. I put the icon so people know what that is. I'm in Germany. Yeah, football, kick the ball. Really love it. And part of the reason I live in England is because I can actually watch a lot of good football there. It's a silly reason, but I like it. Yeah, so obviously it's great to put my face on everything, but it doesn't work that way. I have a huge team. For those that are here that went to the thing, you can see Claudia. Claudia is awesome. I'll talk about her in a little bit. But we have folks all over. A lot of folks are part-time. They drop in from time to time. A lot of folks are kind of key. They check in every week. They give us information on what they're doing. It's really good. And the only thing is it's 6 time zones. And a lot of folks are from Europe. We've got folks in Croatia. Claudia's in Spain. I'm in England. A lot of the folks are over in the US. And then we have a developer over in Indonesia. So I try to sleep as much as possible, but it's not always good. There's 3 verticals in the team. Engineering, obviously. Support, which is really critical, and marketing, which a lot of folks have probably seen a lot of the T-shirts and the stickers and all that stuff. So just a little breakdown of the team. Again, because Light Wallet started as kind of a real passion project from Loshan, it was actually called Loaf Wallet at the time, and he and I worked a little bit, and then another guy, and we were all kind of volunteering, but then we started getting more ratings, better, more users, and so it became kind of a beast. The first team that we really built was with Claudia and another guy. His name is I think Aaron, but that was a long time ago. But Claudia, Leon's a data science guy. He's actually critical to this project because he's a PhD candidate, and he actually went to. Well, I'll talk a little bit more, but his work is critical for this project. Also, we have a guy, Micah, who actually joined us at Nashville. He lives in Tennessee, and he liked what we were doing. He's a DevOps guy, so it's kind of like, oh, cool. We have more people doing more of the kind of the back-end type of stuff. A guy in Egypt, his name's Hassan. Really good senior iOS developer, so I'm as nice to him as I could because there are just not a lot of us rolling around. Patrick, those of you that went to Nashville, you met Patrick, works very closely with Claudia. Josie, we just were in Southeast Asia. Josie and the team went out there and promoted the whole idea of Light Wallet and what it was. And then, like I said, my Croatian team is Mateo. I pretty much talk to him almost every day about what we're going to post and what we're going to do. And his graphic designer, Mahela. Okay, so like I said, this is about the white paper, but the key thing is it's one thing to have data. It's another to have like a big-time quant like Leon to do this. So Leon's been on the team since 2021. He's had to drop in and out because he worked for UCLA, then he worked for a couple of hospitals. That's all he does is write white papers and crunch numbers. He actually started at the time of the invasion into Ukraine, and he's got Ukrainian heritage. So he was like, hey, I want to look at the analytics of people using Light Wallet in Ukraine. So he did what's called a Looker analytic database thing to just kind of look and see, like, what are people actually doing in Ukraine versus all the other venues or regions that we're going through. And it was really cool. And he also, and this is a different white paper entirely, but you guys can check this out. He did a Python library to actually do price forecasting. So I'll show you in a second. But for this project, he took all the data and did some what's called regression analysis to see, like, can we draw any conclusions from the mweb, I guess the peg-ins, peg-outs, all the different parameters. And he's got a website there that you'll pop up there. So people that are interested, he's got a bunch of white papers there. Please check out Leon's stuff. He's fantastic. He's based out of the US. And this is his library. It's like I said, it's a Python library to do Litecoin forecasting. So Shinji's already looked at it. He asked us some really good questions. And I said, like, okay, you're not fabulously wealthy yet, so I don't know how much you're using it, but the fact of the matter is he did a lot of work on this. In fact, I think we're going to do another event with that white paper once we get a little bit more feedback. Also, he couldn't crunch any numbers without the only mweb block explorer website. So Charlie was nice enough to reach out to those guys, and they gave me 2 years of mweb data, which it was activated about 2 years ago, so we used that to crunch the numbers. It's amazing because usually folks are really kind of drag their feet. They've been able to answer all our questions and give us every little bit. In fact, we have an API key, so eventually we're going to actually work really closely with these guys. I feel like they're like a new sector of chain analytics because people are going to start looking at mweb. It's better for us to have inside the foundation and people that really care about this to have a better understanding of what it can imply. Please visit their website. These 2 addresses are there, but you can take a snap of the 2 donation addresses that they have up there. Those guys are fantastic. Okay, so enough for the thank yous. Let's talk a little bit about the white paper and what does this actually mean. And just the first thing you got to realize is there's a long history of what we were talking about when Charlie and I were having, soup and talking about what we're going to do. He talked about confidential transactions. There was no name of mweb yet, but I would like kind of bug him about it like constantly, and he's like, "Yeah, it's not ready yet." And it was very funny. So eventually, I think it was about a year ago. He was like, "Oh, yeah, mweb was live in Litecoin Core." He's like, "Okay, are you ready?" I was like, no. Here's what was happening in 2017 and 2018. Litecoin shot straight up, and even though at the time it was Loaf Wallet, it was there in the store, but most of the work I spent from 17 to 2019 was fixing bugs, getting the ratings up and everything like that. Adding features was just not a thing that could be done quite easily. But fast forward to now, we've got hundreds of wallets, right? It's so hard to actually distinguish one wallet to the other. And so because our team is relatively small in terms of the engineering team, we think really hard and we think deeply about what we're actually going to roll out because we only have so many resources. And the other thing you got to realize is doing alpha testing for something where you really can't track the value is really risky, right? So what we decided to do was say, like, okay, let's go ahead and have a version where people can test it, but it's a subset so that we can actually work with those really technical people. And I was really lucky. So I had been checking GitHub, and I saw, I guess, David and Loshan were looking at L&D, and I saw this guy, Hector, was like kind of doing code reviews and everything like that. And I was like, oh, okay. And I basically just badgered him. And in fact, about a year ago, I kind of like reached out to him. I had about 3 different meetings with him, like 2 hours long, like saying, hey, this is what we need to do. We just need a version so we can put it out there so we can get some feedback, because it is mweb. There's going to be a lot of kind of warts. And he did some great stuff on that. So thank you so much, Hector, for doing that. And also because, again, if something broke, there was not much we could do to fix it, right? So we did a really slow rollout, and we had like the Telegram channel where saying, hey, go check this out and see what's going on. And it's been relatively stable. We first did the launch in January for iOS, and then March in 2024. But here's the problem. You probably can't see that here. I'll go to the next slide. So this was, it's not a year ago, but about 9 months ago, we did a lot of kind of social media stuff to get people to download on Newborn. So we've done posts, we've done stuff in Telegram. It's been slow going to get people to try Newborn. Now we realized, like, okay, we have the branding of LightWallet, but we separated on purpose, because if people think, oh, this is mweb in LightWallet, the amount of people using it would be fantastic or not fantastic. In fact, these are installations that I just got recently. Those numbers are for Android. So Android is typically about 73%. So we're talking about 60,000 installations if you add the iOS stuff. I wanted to make sure that we could separate the two. But we only have about 100, maybe 200 installations of Newborn. It's very early. I'd much rather have, you know, a better end. Now, I will tell you one thing. It's good that we did it, and because we had the mweb data, part of this, and all this stuff is inside the white paper. I noticed that kind of these ramp up. So January, you see iOS was launched, and Android was launched in March. So clearly these are Newborn users actually using mweb, right? And it's great, it ramped up. I'm not sure if this is because this is core or in terms of June, but it's good. It's nice that we're actually affecting it. It was the first, like I said, mweb mobile wallet. And, you know, it's working. But the fact of the matter is these data points, the N is too small. We can't draw too many conclusions because a lot of these mweb blocks are pretty much empty, right? So I'm just showing this. No one can read this from here, but you can go to the white paper. These graphs basically say, like, okay, we have data here. We have peg-ins, peg-outs, mweb amounts, the kind of basic stuff that you would see on the website. But you can't really draw too many conclusions about this. So the only thing I would say, and if you look across this, it's either a 0 or 1, which basically means like, yeah, okay, there's no correlation meaningful, you know, that you can say here. So I hate to tell you folks that, like, we can't really say that there is some meaningful thing going on with mweb yet because there's just not enough users. I mean, it's just that simple. So the first thing I would love for folks to do is take a look at the white paper itself and see what I mean by that. You can look at the data. You can see all the, I guess the numbers are there, but it's like, okay, so what do we do with that, right? And the thing I say with stuff like this where you don't really have a good signal is just say, like, okay, just do it again, right? We are going to launch mweb for LightWallet. And so we have this as a starting point to say, oh, okay, back then this is what it was. And moving forward, we can say, okay, we've definitely grown. I would say these, I guess, conclusions are kind of meaningful in that, like, well, we know this. Number of transactions have a strong positive correlation with block block height. Yeah, we know that because we get the posts every month where we say Litecoin is the most popular coin to use. There is moderate growth, so people are using it, right? But again, most of that is, I think Hector is doing other integrations with like other wallets, so that's helping a lot. But in terms of our sector, what we're looking at is like, okay, I just looked at that data there, and again, my starting point is really, the numbers are really in the noise floor. But it is relatively stable, right? It's getting higher and higher, as you saw in the other graph. So like I said, in the conclusion, we don't really have a lot of resources to analyze mweb data. We just have the mweb Explorer right now. And this is a 2-year-old activate feature, so I'm not going to say it's one thing or the other. I just say that we can use this framework to say do the same thing in a year, right? That's the most important thing. Don't forget that we've done this. We already have the data. We already have the numbers. So let's compare them in a year or so. And of course, I encourage people to take a look at what it's going to look like in the future. Oh, you guys can't hear this. Oh well.
Make sound effects for us.
Right, so this is Profico doing their job of working out the UI, and we spent actually a lot of time having a version of legacy mode versus mweb mode, and seeing how would the UI look like, how it would perform. So that's our starting point for the UI, but the reality is we still have a lot of work to do. So I encourage everyone to please download Newborn, check it out. Everyone's got phones right now. No pressure, no pressure. But yes, please check it out. We've had people that say like, oh, I don't want to pay for anything. So okay, so you can use Newborn. There's no service fees. But it really helps us. If there's anything that's going to blow up, we'd like it to be where we have more than 10% of our users telling us what's going on, so we can actually fix it. And here's a roadmap for I guess Light Wallet and moving mweb in there. So right now, what we're doing is saying, we have the legacy library that does the wallet management. It's called Loaf Wallet Core, actually. We're going to ship LND, which has all the mweb functionality alongside, so it goes into the binary. So it's kind of dormant in that sense. But then there's phase 2 is actually really critical. That means like people that already have transactions that have been using it for a long time, when we want them to migrate to LND, we need to make sure that we don't lose their keys or their Litecoin or anything like that. So we need to put a process inside those. This is before even mweb even goes in, right? Then using the mweb Explorer API that I talked about earlier, we want people that are ready to use mweb or actually to go and see what the chain is behaving, how it's looking like. And then we have the switch, right, which is kind of the video that you guys just saw. And then finally, phase 5 is the kind of, settings, that kind of stuff that we're going to do. And here's a time frame right now. We're working on phase 1. Again, hopefully people won't see that much about that. And when you'll see stuff, it'll be like mid to late October, because we're going to ask you, like, hey, you already have your keys. We need you to migrate to this new thing and double check it, all that good stuff. And when that's good, we'll start looking and saying, like, oh, okay, people are liking it. They're moving over to it. Because in the mobile space, we don't really have control over when people upgrade, right? So we just have to look and say, like, Okay, how many people are like stragglers, right? And when it looks like they're actually moving because it's better. By the way, with L&D, the sync time is much lower. So that's a reason why we think people are going to do that. But then finally, phase 3, 4, and 5 is like I taught earlier. Cool. That's all I have. I don't know if you guys have any questions, but any questions or no technical stuff? Yes.
No, we've got time.
Yes.
A second.
Yes.
Sorry, so just one simple question, I guess, based off of the current look and feel of Light Wallet, which I use as well. When someone's wanting to utilize the mweb aspect of it, they're able to jump back and forth between the two?
That's a good question, yeah.
Or is it something where there's some other process they have to do internally within the app, or is it fairly simple?
No, so if they have their 12 seed words, right, and they want to use mweb right now, they can actually restore the wallet on newborn. So it works even in newborn. So those folks that download and check it out, they can actually look at it. I would say one of the big critical issues in mweb is if you have that. Right now, the library doesn't add all the transactions on the interface. They're still there. You just can't see them because they're mweb transactions. But you can definitely restore the wallet on newborn, which is, if you want to do that, it's easy to do. I do this too, and I don't know why people don't do this, but because I'm doing testing across multiple different devices, I'll have copies of the same wallet on different devices. Right, just to see what the behavior is, right? So that's something you can quite easily do, yeah.
Other questions?
Nope.
No? Okay. We
Awesome.
have a Litecoin panel coming up.
Thank you, everyone.
I don't know if this is actually working.
Oh, that's right.
Hello? Yeah. Yeah, we've got. Hello, hello. Next up, we have the Litecoin Foundation panel. Tonight, speaking in the boy band, the Litecoin boy band. No. Tonight, speaking will be Kerry Washington, David Schwartz, Loshan, Charlie Lee, Alan Austin, and David Burkett. Let's put our hands together. Thanks.
Well, thank you very much. My name is David Schwartz. I'm the Director for Strategic Partnerships for the Foundation, and I'll just introduce everybody as we go this way to the left, and from there we'll get into the talk. Next to me we have Charlie Lee, the creator of Litecoin, one of the board members. Loshan, one of our key developers for Litecoin, as well as David Burkett, who works on mweb. For Litecoin, Alan Austin, the managing director for the foundation, and then Kerry Washington, who spearheads the Light Wallet team. So the title of the talk is Proof of Human Rights, and that can be, at least in my mind, a little bit subjective in some ways, right? So what I'd like to do is just possibly get where you feel Litecoin is a contributor to well, maybe not necessarily the human race, but just globally in some general form, how you feel like it can be an advantageous thing for people to be utilizing, or how it helps within the monetary system as we see it today, and then go from there. And then we can feed into other topics from there. So if each of one of you could see how, or speak about how you see Litecoin helping the world in general, the way it is right now, I think that would be a good start. Charlie.
Start. Well, I mean, like, money has been used to control the population throughout human history. So I think having a good sound money is really important, and Bitcoin and Litecoin plays a role in that sense. And I think, yeah, I think it's very important to have money where it's free. You can use it however you want without anyone being able to tell you whether or not you can spend your money.
Okay.
Yeah. So for a long time, humans have been using cash and coins, and there's been almost perfect privacy, and there's no programmability to the money, so you're not blocked from using your money for whatever reason. And when we've progressed to the digital age, we've actually seen like a regression. But I think Litecoin can be equal to the previous
forms of money.
Yeah, I think Litecoin in particular is close to what money is supposed to be. It's fast settlement. It's relatively stable value. Rather just shoot right up, but but it's fairly stable value. It's an easy way to transfer value from one person to another, which is crucial aspect of money.
Yeah, I mean, everything that's been said, I think censorship resistance is very important when it comes to money, the ability to control your own finances, and also have the ability to have some added confidentiality when you want to have that is very important to money, sound money.
Yeah, I mean, for me and the Light Wallet team, we look very closely at countries that have weak currencies, and they love Litecoin. It's like the perfect thing to transfer value. So it's clear, I see it every day. It's obviously the way to use currency, digitally.
So I've heard a few different things. Charlie speaks on the idea of fungibility, which is obviously key when you're talking about money specifically. I've heard of something returning to the sort of like the precepts of what cash and other forms of payment were. Also freedom of money, and then last but probably not least, for sure, would be access to Litecoin or forms of cryptocurrency like Litecoin by perhaps more underprivileged countries, or countries that have a harder time finding something stable for themselves to use. Not necessarily ranking any of those, but if we were to take one and then just build off of from there, if we took the term banking the unbanked, can be something that a lot of people try to use when they speak about cryptocurrency or Bitcoin in general. Do you see any problems with that term necessarily versus the actual reality of banking somebody who's unbanked? And anybody can speak up on that.
Yeah, I mean, again, if you talk about these underdeveloped countries where, most of those poorer folks are using cash, right, or barter or something like that. And I think, unfortunately, a lot of people that came up with that term or use it in the, developed countries. So for them, it's a concept. But for people that really can't get a bank account, they're doing some other things. So we're offering another option to them that's not really that hard to figure out to do. I just went to Indonesia, and that's the 4th biggest country in the world. The currency is really weak, and they love crypto there. So they might as well use some Litecoin. It's just that simple.
Anybody else on that? So if we were to take that concept, do you feel like it would be something, and anybody can answer this, but do you feel like it'd be something where it's running a parallel financial system to whatever the local state currency is, or is it something that you feel could actually overtake or supplant it and then be the majority currency that's used within a country? Or do you feel like it's something, as I said, maybe it just runs parallel and somebody's able to access and go back and forth between the two?
I think choice is important, and then let people decide. I think a lot of it depends on the nation's currency and what's going on with that at the same time, and what Litecoin, say for example, could offer that's that much better, and in how it's in which ways it's better. I think it's very important, for people that need to be banked, banking the unbanked, that they can also spend and be able to buy goods and services, because that's very important for people's lives, livelihoods, and the ability to do that in an easy way and in an inexpensive way, and a seamless way is very important on a day-to-day basis. So I guess that's a hard question to answer if it'll ultimately replace or not, but I think it doesn't necessarily have to continue to gain adoption if it's a better solution.
Yeah, I think they're large. I think that's kind of more of a larger scope type of a question, but if we were to maybe drill it down a little bit, just based off of knowing you guys here on the panel, many of us have either family or ourselves. We live in countries outside of the United States, right? And one of the biggest ways of keeping contact with family or people that are close to us is through sending money also, right? So remittances are a big deal globally. Do you feel like that's maybe a track of where a Litecoin or a Bitcoin or something similar can take a large market share of that and actually be of use to people who are trying to send money back and forth between countries?
That's one of the key things about crypto is that it's borderless, right? Being able to send money from one country to another country without any restrictions is kind of very critical. And something I found early on, if you try to even use your credit card in a different country, it may not be accepted, and it's just hard to transact in another country. If you travel to China, which I've done quite a few times, it's not easy to spend money that you have in the U.S. And with crypto, all you have to do is scan a QR code or something. You can just send crypto, and the fact that it's borderless is very powerful.
True. Anybody else want to chime in on that at all, or?
I actually need to send some money to the U.S., and we're at the ECB, and they don't have an ATM. It was frustrating, but it's going to take me a week just to move $300 to the U.S. It's maddening, right? So
I feel like the services that already have a foothold in that area, even if you talk about a PayPal or MoneyGram or any of those, they have added cryptocurrency as part of the selection for sending, which to me seems a bit ironic in the fact that it's...
Well, they charge 20%.
Right.
Yeah, 20%. And a flat fee too.
Right. One, you end up still having those same types of fees. Two, it's a third party that's involved, which, for all intents and purposes in the world we live in, you almost could migrate away from that fully if there was really the intent and the resources behind it to have it happen, right? But most likely you're still going to have those types of services around. But if you move from remittances, which is being able to help people on a daily a daily basis in their life, how can you then also sell those same people, or maybe not sell them, but at least advocate to them in some capacity how those remittances could also be used to store value and then have that value grow over time without having to necessarily put it in the hands of anybody else and keep it for themselves, or it's under their control during that time, pass it on to their family or somebody else? What would you use as maybe like a selling point for that, where then now not just using it to send it from perhaps the United States to Australia, but then also have that person in Australia take it, make it part of a quote unquote portfolio that they use for their own, generational wealth to pass on to others? What would you use perhaps maybe like as a selling point for that, other than what I just said?
It keeps you connected to the global economy, I think. Just the fact that you've always got it available there to send. There's no even if there's local changes in the regulatory, landscape, if you've got those coins already, you've got that value stored, you always have a way then to participate in the global economy, even if things go south locally. So.
Okay.
Well, the key about cryptocurrency and Litecoin is that nobody can devalue your money by printing more of it, right? So unlike their local currency, it's good sound money. So just by that principle, people would want to keep their money in Litecoin versus their local currency and only exchange it to their local currency if they need it.
Right, so the rules are already in place and they're fixed and it's not going to be changed from there. Do you feel like this is a race? Do you think this is a race to where there's only one legitimate cryptocurrency that can be utilized going forward? Or do you feel like when people say freedom of money, there's an actual option to have the money that you prefer to have? Or do you feel like it ends up being something where really they just sort of choose one to advocate for? And when I say they, I'm talking about obviously the powers that be that already pretty much facilitate what happens in the world.
I think that.
Go ahead.
Sorry. I think that there'll be multiple different cryptocurrencies that will be used by people, because certain people will prefer different things over other people. Some people, for example, it's important to them to have ease of use. For some other people, low fees is what they really need, because the country, the amount of money they make it would be too much to pay for fees, but if they were, for example, using ETH or Bitcoin. So there'll be multiple different cryptos with different technologies, different use cases. Yeah.
Okay.
Yeah, I mean, I think people will, as long as there's choice, people will always want choice. And if there is no choice, that means that sort of goes against the whole idea of decentralization, right? So if there's no choice, that means that something is being controlled to a point where there will be a push to have other choice. So I think there'll always be options. I don't think they'll ever change. It's hard to say what will be popular, but Litecoin's goal is to be the best money possible, and make it also not just a store of value, but to be able to be used, facilitate. I think it works better the more people that use it. For example, so if you go to a restaurant, for example, and you're able to pay with Litecoin, well, if that restaurant can now use that money to buy their supplies, pay their employees in Litecoin, those employees can then use their Litecoin for say their rent or something else. The more circular it is, the less reliant that we are on a traditional system, and the better I think everything works ultimately.
So in 2021, about a little over 3 years ago, the great experiment happened where El Salvador made Bitcoin legal tender in its country, or at least that's when he put in the bill for that, and then it was passed. Since then, they've had the Chiva wallet that was utilized by Salvadorans, where I think it was about $30 or so of Bitcoin was put into each of these wallets. The end result was most of them just pretty much drained it and then used it for their normal, day-to-day lifestyles. And then from there, obviously, you have a buildup where, not necessarily if it's Chiva wallet, but more Bitcoin usage on a daily basis than what was there in 2021. It also had some effects locally within other areas of the government. Crime is down. Obviously, that happens through other actions outside of Bitcoin, but you have people who attribute basically the cleaning up of the country to Bitcoin being added as legal tender. How do you see going forward on the human rights side of things, cryptocurrency playing a role in not necessarily eliminating, but at least mitigating some of the evils that happen within the world and fighting perhaps hyperinflation like countries like Nigeria and others that are experiencing that right now?
It's funny, actually, you bring Nigeria because I think they're kind of the crucible of countries that are very dynamic in terms of like the N-ary and everything like that. We typically have around like 6th or 7th activity on Light Wallet is Nigeria. There's a lot of folks all over the world from Nigeria, and they're really savvy about currency and business. I think if you look at that populace, you realize like they're not going to take any mess, right? They're going to figure out a way to do it, right? So as bad as the government is in Nigeria and trying to clamp everything down, people still figure out a way to do it. Maybe it's not the best optimum situation for them, but they're still using, I think activity is very high there. And most of it is remits to other countries.
Mm-hmm.
If we think about when Bitcoin came onto the scene and somewhat why, one of the reasons it got big, like the landscape in 2008 was such that like inflation had, money printing had led to these crazy house prices and this major crash, and the Austrian economic viewpoint was starting to gain a foothold amongst a small crowd throughout the world. But to see like Bitcoin, how it was so much better at like it would perfectly guarantee that there would not be this kind of printing, this corruption to like fund these special interests or just to print endless money for whatever purpose. Like it has guarantees built in that that it won't be inflated away. And I think just like any country that's seen any kind of massive inflation event can should be able to see the obvious benefits of this, of not having one controlling institution just manipulating the money at will.
Yeah, that leads me to two other questions. One has more to do with simply users and how they either have access to or hold that crypto, right? And then the second question would be based more off of sovereign states and their decision to either maybe begin a treasury based off of crypto or not, or how they utilize it for their, potentially even some sort of defense of their country, right? So let's go back to the wallets, which is first. When we're talking about a Nigeria or some other country, perhaps that doesn't have all of the electronic capabilities that a United States or somebody else has, what are some of the different means, or how would you see them potentially holding it the majority? Like if they don't have the internet available always in the areas that they're living in, paper wallets, are they going to serve the same principle? Like would they end up having to perhaps print paper wallets that have X amount of crypto on them to begin with, and those are then used within a certain amount of time? How do you see that banking the unbank happening for people that aren't?
I would say, well, I assume you're talking to me, but the funny thing is it's really fundamental. We spend a lot of time, when my teammates are here on customer support, and they spend a lot of time just reminding people to just store their seed, write it down somewhere. That's still a huge problem. So it doesn't matter how strong your economy is, if you don't have a good process of saving stuff, putting it away. It doesn't matter, if you're, in America or in the middle of, Peru in some village. If you don't do that, no one can help you, right? And so I think education is so important. So we do a lot of our marketing is like, hey, this is important. We do it in other languages so that people realize like we don't control this. And if you have another wallet, you still need to manage, whether it be like a trust wallet or anything like that, you still have to write that stuff down. You still need to protect it. And that should be like table stakes. Hopefully we can do that where it's so common, but it's not there yet.
I think a lot of this is education too. I mean, and just going back to like adoption, it really comes from like understanding and sometimes having to learn, hard lessons. I think going back to El Salvador, for example, like you said, a lot of people were utilizing these wallets just to get the free Bitcoin. If something's being pushed by, say, a government, I mean, is that good or bad? I mean, it depends on how much you trust your government, right? So I think some of these things have to come from understanding why something like a Litecoin or Bitcoin is important, not because it's being pushed on you by somebody else, to really naturally grow for the long term. So just kind of touching back on that. Maybe with the El Salvador thing, it's just, I think their direction is right, but it's still early on. And when you're pushing something kind of hard, it takes time for users to really understand why they're doing something.
I think back to your original point, the nice thing is that most countries have a very robust cell phone network. So and almost every citizen have a phone, no matter how poor they are, which is kind of crazy. And as long as you have a smartphone, you can download a crypto wallet and be able to get onto this alternate monetary system without permission, right? Without requiring permission. So that's really key. Anyone with a smartphone can use Litecoin and can be their own bank.
Do you feel like some of those hurdles may not be as high as possibly perceived, at least initially anyway? Or?
Yeah, I think, yeah.
Okay.
The fact that people have cell phones or smartphones is
I think it's
very powerful.
I was really shocked to learn that, a couple of years ago, was that, just how prevalent cell phones are even in the poorest of countries.
Yeah, like in
to know
India,
there's always
everyone
that
has a
weak-
cell phone, even
Yeah.
though it costs a month of their salary.
Yeah.
I personally, I've never used a paper wallet. That's something I always wanted to experiment with, but I've never gotten to that point
It's
yet.
not really for transacting.
Yeah. So that was going to be my question is if from those of you that have had that experience, what's the progression been like in self-custody or any type of custody from, paper wallets to the point where we're at now? Like what are the key things that you've seen, either hurdles that have been knocked down or potentially things that still we have to address as a whole?
I mean, so the evolution of the wallet storage technologies is it's basically from really insecure ones to slightly less insecure. And I think as far as other countries, seeing the older technologies and stuff, there's not really any reason. We have a much better system now, the seed wallet type hierarchical, and I think that's pretty usable throughout the world. So I don't know if that really answers.
I think that a lot of people realize that self-custody is very important now compared to a few years back, and they've seen all the hacks and the drains and whatever happen, and over time, self-custodian wallets are getting easier to use. There's been improvements to technology, so the sync speeds are faster. There's been less issues compared to custodial wallets. So the technology is improving, so is the education. So I think there's been improvements over time.
And there's now multi-signature wallet solutions and other things that often make it sometimes even easier and safer, depending. And so, but there's still a responsibility to self-custody and a lot of education that people need to understand.
Okay. I would say this, I'm sorry. Yeah, I would say it's a lot easier to pitch to save some words than say, oh, here's a paper wallet. How do you use it? Which wallet does it? Can you do a sweep into? I think a lot of tech are not technical enough to understand that, but they know how to write down some stuff and put it away.
So to continue where you're talking about on the technical aspect of it, right? So I probably have the least amount of time in this space, and I've been in since 2017, right? So I'm the one that got my parents into crypto. I'm the one that got my wife into crypto. I'm the one that got all my parents' neighbors into crypto. But even with my parents, the first time I gave them any Litecoin was to pay for some rent. So I gave them some Litecoin instead to get them introduced. So I basically forced them into it, right? But even then, they only knew whatever I fed them, right? So when you're talking about generations that are 60 and older, if you're not directly feeding them the information, they're probably not going out looking for it because they're used to somebody providing the information for them. So even though in 2017 I paid rent for 1 month in Litecoin, and I sent it to their wallet, I actually had it sent to Coinbase first because I had them open up a Coinbase account. But if you don't go through the process of actually linking your bank account, you have no way of offboarding it, right? So it's still sitting there on Coinbase for the last 7 years because they themselves did not take the initiative to figure out how to link their bank account to it, right? It's the only reason they still have it. Otherwise, they probably would have sold it by now. But in the meantime, in the last couple of months, I've forced them to put it onto their own self-custody wallet. And then they're going to have to start trying to figure out how that works too. But they won't because it'll be up to me to show them.
To do it, yeah.
Is there anything that you guys can give as far as advice to those who have somebody who may not either have the drive or the capabilities at whatever age or whatever, limited reasons as to why they wouldn't understand more than just the fact that here I've put this on this wallet and just, watch the price go up or down every day?
I'm crypto.
And I'm sorry, I asked this because ultimately this becomes a national thing, right? If there's ever a time where it's like crypto becomes an important part of a nation's financial system, there's going to have to be an education curve that hasn't necessarily started yet, right? So like as you saw in El Salvador, as soon as they got that $30, they drained it, right? So what would it take from a national standpoint in order to educate individuals on what this really means and how do you actually use it? And
yeah, I yell at my brother quite a bit about this. I mean, he's not technical at all, so I'm his crypto IT person, and I just tell him just do it. You have access. I'll go do something else, right? Because a lot of people like the excitement of trading, and he's one of those folks. And I say, no, you need to know what you're doing. So every few months we do some work together. I don't know how much it's sticking. It's really difficult. I don't know if there's a good answer for that, but you just gotta love your family.
My father-in-law doesn't even have a smartphone or anything, and lots of grandparents that don't have anything. I think there's a lot of things that are just generational, and they just almost have to grow up with. Or if everyone around them has grown up with it, then we have gotten my grandma has a smartphone, and we never thought that would happen. So it just when everybody around them uses it, has grown up with it, it's so ubiquitous that then they finally may adopt. But I think it's a challenge just to go and try to, teach those who are a little more stubborn and stuck in their ways.
It's like every single old person uses Facebook now because everyone else uses Facebook. So you just have to onboard a few, and or you can just, I guess, wait for the old ones to die off.
Either or.
Yeah.
Thank you.
I'd like to open it up for questions.
Oh, there's one.
We answered all of them.
No, let me gently push back on something regarding education curve, because that's something we've talked about in crypto since basically 2010. And back in 2010, that was kind of a good argument, and it was just very, very complicated to get started with it. I mean, okay, it was less because you could just download Bitcoin and still mine it, but starting in 2013, that was gone as well, and so it was complicated to obtain them. But the reason kind of products get adopted basically is that the education curve is so low that people can just very quickly do this. And that's obviously a big question is, which you kind of started on, is onboarding off-ramping. And that's kind of, I think, the biggest challenge, because we can make the wallets, etc., easy enough that there's no problem with people using them when they use them, because they look like any other apps that they use. But I think the education learning curve is something we need to minimize, but then we also need to have the ability to really on and offboard people quickly.
Yeah, I would agree with that. I think at least for me, in the position that I hold, and some of the entities that we talk to regarding either working with them on something as partnerships go, or helping to promote the things that they're doing, their core demographic that they're shooting for is not the people that I was speaking about, right? It's usually the people that are probably 18 to 35 years old. They're already very savvy in these things, and that's the demographic that they shoot for, because ultimately, who are the ones that are going to teach the ones that are older? It's going to be their children or their grandchildren or whatever else. And so, yeah, it's interesting. I think there's sort of like this cyclical thing that's happening, and we're sort of in the middle of it. There's a transition period where the young are now teaching the old again. And I wonder sometimes, with the frailty of a lot of elderly people in the positions that they're in, and they already get taken advantage of many times, how do we educate them so that they're not clicking on those emails that are obviously phishing bait? I mean, there's so many different aspects of that education curve that I don't think we're addressing necessarily right now.
Not to mention even like AI deepfakes and voice fakes that are coming down the
Absolutely, just to
pipe.
make everything even. Like you get those calls where it's like, this is your grandson, I'm stuck over here and I need, $1,500 for the, whatever it is. And then next thing you know, they're wiring the money without.
And it's not just older. I just had, I was introduced to somebody through a friend that was unfortunately, using kind of pulled into a con exchange and sent a bunch of money, and he was scammed out of that. And, and he was much younger than I was. And he's like, I don't want to ever deal with crypto again. If that's your first experience, it's a tough one.
I have a question actually. So you mentioned, freedom of using whichever money, and we do have that. There's a number of different coins, and I'm much more familiar with the Bitcoin world. But what I'm curious about is where in the world you're seeing like a larger prevalence, for example, of Litecoin adoption. Like, is it regional?
Oh, absolutely. I would say, and obviously they can fact check me, but I think the majority of it's being utilized within 3 main geographic areas. It's mostly the United States, which is the heaviest. You also have Asia and then Europe. Right.
Is there a reason that you guys would infer potentially like why those patterns emerge?
Bitcoin blocks get full and they get really costly.
You're talking about
right?
the specific areas more so.
Yeah, I mean, the fees can be, US dollar and Litecoin is not even the case. Nowhere near that. So I think we always do quite well every month.
Some of it I think is just based off of the fact that there's a door already opened by Bitcoin, and then that's where it ends up being adopted next, right? So like the continent of Africa and a few other places, not so prevalent for Litecoin, right? But as Bitcoin gets adopted into those areas, then naturally people get curious and they find out about other options that are available, and then that's when things like Litecoin or others get introduced, and then those people are making those choices based off of it. But it has to be available liquidity-wise first, most of the time anyway, unless it's somebody like a Loesch or a David or somebody else who's sending them some because of whatever reason, right?
Thank you. Any other questions from the audience?
So my question is, why not educate kids?
Why not what?
Educate kids. We have 4 kids, for example, at age from 4 to 12, and we start with them to educate how to use, for example, in this case, Dogecoin as a currency at school, that they can also teach other kids what is it. And we adults, it's normal, it's our way. But when we were younger, we learned the hard way how to use Nintendo or use the X Spectrum, and was us as kids that teach our parents. And I see also in this way that kids are the way to mass adoption. I don't know, what is your opinion about that?
So teaching the kids first.
Yes.
Yeah. Yeah.
We've definitely seen the power of marketing to children, for better or worse. But I definitely they are the most capable of thinking differently about things, of
probably
not
more
being
open to
stuck
whatever
in their old ways, because they have no old ways. So yeah, they would certainly that would be a cool thing to do.
I've read of many people who will have their children do their normal chores and then pay them in a crypto instead, right? And then that's how they get started on it. Then you have some to the extreme of like Elon, where he's got his child mining Doge, right? So he's already understanding how that all works. So yeah, I do believe that's important. And I think those are probably the most prevalent ways in which to do that. I think there are some schools that are I mean, you start seeing it bleeding down from the university to the high schools, perhaps hopefully soon into the grade schools where there's education of how crypto works or blockchain, you know.
Because the learning curve for kids are easier.
Yep. Yes.
Adults, we are not sponges.
It's already saturated, right? It's all full, yeah. I agree.
I've seen some use cases for crypto in video games, and I feel like young children who play video games, if they're kind of forced into it, they do want to learn about it because they feel that they can maybe make money or do something like that, like micropayments through video games.
My children know all about Roblox, I think they're
Roblox.
called. And V-Bucks and all this other stuff. So yeah, it should be very natural for them to learn about other digital money
So
forms.
Thunder Games that does real Bitcoin, like Satoshi rewards.
Yeah.
Yeah.
All right, we have time for one more question. And if not, we shall take a break and be back at, I believe, 4:30.
Great.
Thank you.
Thank you.
Thank you. Awesome.
Shall I close?
Sure. Our second last speaker today is Donald McIntyre, senior editor of the Ethereum Classic Cooperative, and he also used to work for UBS. He was a former consultant at UBS and Morgan Stanley, and is a senior blockchain expert. So this talk is going to dive into the threat of CBDCs on personal privacy and property rights. And Donald is also going to provide us with a comparison of CBDCs and Ethereum Classic.
Thank you, Mag. Thank you, Mag. Very good. So the first part, I'm going to talk about ETC and ETC for developers, for dApp developers, and Web3 developers. What are the benefits of ETC for them? So, hi, I'm Donald McIntyre, senior editor at the ETC Cooperative, as Mag said. And in this speech, I am going to talk about why you should build on Ethereum Classic. This is for developers. And the threat of CBDCs, comparing Ethereum Classic with CBDCs. The value of ETC. As a proof-of-work blockchain with smart contracts, ETC has the most valuable position in the industry because after the move by Ethereum to proof-of-stake, ETC became the largest proof-of-work programmable blockchain in the world. That is digital gold. Proof-of-stake smart contract blockchains are insecure, and proof-of-work blockchains without smart contracts are less versatile and less secure. Why build on Ethereum Classic? First reason is ETC is proof-of-work. That ETC is a proof-of-work blockchain makes it truly decentralized and trust minimized. Therefore, your dApps will provide great safety and confidence to your users. Here. Second reason, ETC is hard money. ETC is hard money, hence it will keep its value over time, and your users will be enjoying a cryptocurrency that will protect and increase their savings in the long term. 3, ETC is programmable. ETC is programmable, therefore you can build valuable dApps with utility and governance tokens inside its highly secure proof-of-work environment with no need of bridges, external connections, and proofs. This Proof-of-Work Summit has been very interesting because people like Sergio Lerner came and explained these issues of the bridges. And part of his explanation, bridges are these connections between layers. Now you have Bitcoin, and then you have a layer 2. The connection is the bridge. And then you have Ethereum, and you have the layer 2 roll-ups and all these things, and the connection is the bridge. The bridge requires a deposit of the money in the layer 1 network, and somehow the token, the wrap token, must appear on the other side, and you have to make sure that nobody's going to steal that money. It has happened already, hundreds of millions of dollars lost with these bridges. So these bridges will always be insecure as long as a blockchain, as long as a system is separated from another system, the security of both systems together is always going to be lower as the security of each system independently. No? This is to say these bridges and layer 2 systems will never be as secure as Bitcoin internally. Bitcoin as a layer 2 and transacting inside Bitcoin. The same applies for Ethereum Classic because Ethereum Classic is proof of work, which is not the case for Ethereum, which is a proof of stake, therefore centralized, therefore insecure. The fact that ETC has the smart contracts, the accounts, the balances, the nodes, the miners, everything integrated in the same layer, that is what makes it extremely secure. And another thing that was interesting about Sergio's presentation, I recommend people to go and see the Proof of Work Summit video of Sergio presenting the bridges to Bitcoin, is that he did the comparison of security of the older bridges and the new bridges, and he basically declared the problems of security of these systems. which in a way affirms my argument. The fourth reason to build on ETC is that ETC is fully replicated. ETC is fully replicated, which makes it extremely redundant worldwide, making your dApps uncensorable and capable of surviving a nuclear war. Now, that was the original intent of Bitcoin. It's full replication is the security model of Bitcoin, and you needed proof of work to achieve consensus. But the security to replicate the ledger and the smart contracts and everything in all the nodes globally. So any system that does sharding or side chains or layered approaches, etc., because they're not fully replicated in every single node, then the security is lost. The original most intent of the security model is lost. And it's incredible, and it's a shame, I would say, in this industry that a lot of people sell their systems as if they are better, but they're not. The simplicity of Bitcoin and Ethereum Classic as fully integrated systems is the best model. The fifth reason to build on ETC is that ETC is composable. This is another benefit of this integration. ETC is composable, which means that you may build dApp systems, or your dApps may interact with third-party dApps that may execute multi-application transactions at once, saving gas fees, reducing settlement times, and increasing convenience to users. Composability is another thing that is lost when you create these layers. Let me go. We are here. When you create these layers and you fragment the components and the functions into components or layers or using bridges and things like that, then you lose composability. For example, when you came here to the Proof of Work Summit, you went to the website, you bought the ticket to come to the Proof of Work Summit, then you bought an airline ticket to come to Frankfurt, all those who are from another city. Then you, or another country, then you got the reservation for the hotel, and maybe you bought something else, as part of the trip. When all those things in a composable system like Ethereum Classic, because the smart contracts, the accounts, the balances, the nodes, the miners, everything is in the same system, you can do it in one single transaction. You say, I choose this, enter, and everything is executed in all the dApps at the same time, even if they're different providers. And that can also be done, for example, in the future using NFTs, buying a real estate, for example, that is represented as an NFT inside the blockchain, and you take the mortgage loan, the loan to buy a house, for example. The house is the NFT. You have a smart contract that is going to lend you the money. You put 10%, for example, 5, 10, 20% of the money into the transaction. Then the title is going to be given to you. You press enter, and all these parts in the transaction are going to be done in the same transaction in 12 seconds in the case of Ethereum Classic. And you're going to be the owner. The real estate is going to be, or the house or the apartment is going to be transferred to your address, meaning legally, when it's recognized officially, that you're going to be the owner, when today that takes 30 days, 60 days, usually in normal systems. And you're going to receive the loan, and in the future, if you don't pay the loan, the mortgage loan, the payment, say that you missed 8 months of the payment, then the lender can claim the property back and sell it in the market and pay off the loan and things like that. So the whole process of many kinds of transactions can be done. Today, these things are not possible in the legacy system or in sharded and separated systems that are layered or separated in components. But in the legacy system, for example, Citibank is one thing, HSBC is another thing, Deutsche Bank is another thing, Visa is another thing for payments, MasterCard. All these systems are separate. The airlines are separated, the hotels, Holiday Inn doesn't talk to United and things like that. And to do transactions, you have to go to each provider individually, and it's impossible. The systems are totally incompatible. So the composability is an extremely important part. 6, ETC is the largest proof-of-work smart contracts blockchain in the world. ETC is the largest proof-of-work smart contracts blockchain in the world, meaning it is extremely safe and difficult to attack, which makes your dApps much more stable and persistent than in all other blockchains. Ethereum Classic, when Ethereum was still proof-of-work, Ethereum Classic was not the largest proof-of-work blockchain in the world, but when Ethereum moved to proof-of-stake, which I think is like suicide, Ethereum Classic rose. It received a lot of the miners. It has a very high hash rate now, and became the largest proof-of-work blockchain in the world, which affirms all of these features that ETC has. 7, dApps in ETC are the most secure in the world. Because ETC is proof of work, hard money, as I explained before, programmable, fully replicated, composable, and the largest in its segment, this means that your dApps in ETC will be the most secure apps in the world. This is more secure than military-grade applications, government, or corporate systems. This is very important, very difficult to understand, no? But the Pentagon, the US military, the Chinese military, the Russian government, the Russian military, all their systems, even the most secure systems, their spy agencies, etc., are less secure than Ethereum Classic. In Ethereum Classic, when you send an application, it's immutable, unbreakable, unchangeable by anyone. Nobody, even China, the US and Russia, if they got together to try to do it, they wouldn't be able to do it. While military systems, they depend on the officers and people, and this makes them very vulnerable, hackable, and things like that, attackable. So this is a very incredible concept that Ethereum Classic is the environment where the most secure applications can be in the world. 8, ETC is code is law. ETC is code is law. This is a philosophical point, very much like Bitcoin, which is a guarantee of immutability of your dApps and future backward compatibility. 9, ETC is Bitcoin with Ethereum technology. ETC is Bitcoin, but with Ethereum technology, so your dApps will enjoy the best of both worlds from the most important inventions in the industry. So for me, there's only 2 inventions in the blockchain industry. When Bitcoin was invented and launched, Bitcoin itself, the network and the hard money, etc., that's not the invention. All of those things already existed. All the components of Bitcoin already existed. Even the Hashcash, the proof of work function, etc., already existed. But the invention is using proof of work as the consensus mechanism. That was the invention. That was what is revolutionizing the world, because now all nodes in the system globally, just by receiving the block and checking in their own isolation without having to depend with any third party, they know that that is the last block. That is amazing. Proof of work is the first invention, and the second invention by Vitalik, amazing, brilliant invention, which is smart contracts. Now he put Solidity, he put the EVM inside a system like Bitcoin with proof of work initially. He added a programming language. He added the gas system, which is brilliant. And he created smart contracts inside the blockchain, where you could move money according to sets of rules and things like that, and build applications. So for me, those are the 2 great inventions. But if you think about it, Bitcoin is proof of work, therefore very secure. That is the consensus mechanism, and the security is there. That's why we do this conference, and everybody talks about Bitcoin, because here in this environment, we know that. But Ethereum was proof of work, but they moved to proof of stake. So they are smart contracts, but they are not proof of work. So there's no integrated system that has proof of work and smart contracts. But ETC is that. ETC is a proof of work smart contracts blockchain, and has everything integrated. The 2 inventions in one system, and that is very unique, and it's the largest one in the world at that. Okay, let's talk about CBDCs, the threat of CBDCs, which is the topic that has to do with these things and human rights. Let me go to the right slide. This meme was made by Bitmain, a strong supporter of Ethereum Classic. Oh no, I'm going back. Okay. Soon, the threat of global government digital passports, CBDCs, constant health emergencies, and climate hysteria, as seen by the attacks on proof of work that we've seen in this summit, will tend to enslave us. Once the elites know each of our transactions and gain the ability to control them, they will impose their worldviews on everyone on a global scale. They will stop purchases of meat on the grounds of the government-recommended food pyramid, stop purchases of gas for our vehicles on the grounds of climate change, and cancel donations to churches on the basis of national security. The only escape to the calamitous global absolutism that is coming will be non-compliance. And non-compliance will only be possible through technologies such as proof-of-work blockchains as ETC. It's very important for every one of us not to use CBDCs and not comply and use ETC and Litecoin and Bitcoin. As central banks all over the world race to launch their central bank digital currencies to please the global elites such as the World Economic Forum, we as citizens have no other recourse but to learn and understand what these new technologies will entail to our life, liberty, and property. To explain what are CBDCs, a good way of going about it is to compare them with Ethereum Classic. ETC is the most secure and advanced blockchain technology in the world, and CBDCs seek to imitate its design, but to add to them their central control and planning devices. I mean this, that CBDCs are, they usually use Hyperledger, which is an EVM system as well, and ETC is part of the EVM ecosystem. So the comparison of ETC as an EVM system and CBDCs is what I'm doing here. Bitcoin was not useful as a model to follow by them, as it was so basic that it didn't enable any kind of central planning scheme or control. In the next two sections, we will explain the contrast between ETC and CBDCs and how the design choices make them completely opposite in terms of human rights. This is incredible, because ETC it's the same design, it goes in one direction, human rights, basic rights, and protection of individual. And CBDCs use the same design, but they go in exactly the opposite direction. The differences between ETC and CBDCs show the intent, the differences, no? The ones that are highlighted now are the differences. Show the intent of the designers of central bank digital currencies. That they use proof of authority as the consensus mechanism shows that what they want is complete centralization and control, where censorship and gatekeeping reign. That they will not have cap supply show their intent of boosting modern monetary theory, which is basically printing money all the time, where the state monopoly of money can print whatever they wish, while households have to live with a consequent inflation and constant transfer of wealth to the rich. This makes CBDCs totally centralized systems, while ETC is decentralized, has a cap supply to protect users' wealth, and uses proof of work as a consensus mechanism, which is the only way, which is the only one that is truly decentralized. But the most nefarious and incredible thing is what ETC and CBDCs have in common. So now the highlighted features are the ones that are in common between the two systems. Full replication, smart contracts, and composability enable all nodes in the system, which will be the banks, intelligence agencies, governments, and supranational organizations like the UN, World Bank, European Union, WHO, etc., to see all the transactions and information in the economy in real time. Imagine Bitcoin and Ethereum Classic and Litecoin and Dogecoin. The nodes and the miners are whoever they want to join in the world, anywhere in the world, and they can join and leave whenever they want, because that's the feature of proof of work, not proof of stake. But CBDCs, nobody is going to be able to be part of that except the people they authorize, and that is the central bank, the government, the CIA, the World Economic Forum, the World Bank, the European Union, the European Central Bank, and they're going to see everything we do. We come here, we pay for something, a coffee, and they're going to see it immediately, because a transaction is sent to the network and spread in a matter of seconds. Actually, Sergio Lerner also yesterday, he showed like in 2 seconds how the transactions are spread around the world. So for them, it's the best thing that it's much better than the legacy systems that they already control, because they can control our lives as we operate, as we live live on the spot. In 2 seconds, they know what we're doing. This will enable governments to monitor all our human action and score us. They're going to use this information to score us, no? Individually, and control our behavior based on our politics, cultural background, their climate policies, diversity, equity, and inclusion ideology, critical race theory, and environmental, social, and governance rules in the case of small businesses and corporations. So all of us here who believe that these are things that are good, they're going to be used for evil. They're going to be used to control us. All this of climate change and racism and poor these, the Palestinians this and the Jewish people that and all these feminism and what's going on with the immigrants. We have to protect the immigrants. All of these movements, they fake that they care about these people, but they're really brainwashing us to lure us into the system and control us. With these technologies. However, because ETC is truly decentralized, full replication, smart contracts, and composability have exactly the opposite effects. In the middle of the techno-tyranny that is coming, and this is coming, it's not that, oh, maybe, or no, it's already here, I would say. Especially here in Europe. Europe, for some reason, is leading the way in how they control their people. I mean, they're controlling speech, like in the UK, in Germany, arresting people for what they say on Twitter. Well, outside of Europe as well. In Brazil, they already banned Twitter. ETC will enable us to enjoy our full natural rights, such as life, liberty, property, freedom of contract, free speech, freedom of assembly, and freedom of religion. This is because full replication, smart contracts, and composability will exist in ETC in the context of a totally censorship-resistant and permissionless proof-of-work programmable and cap supply blockchain. To learn more about ETC, please go to ethereumclassic.org. Thank you very much.
Thank you. Do you guys have any questions?
Anybody has any questions?
You mentioned that those token attacks happened. Do you mind?
There were what?
Some token attacks, or because of the bridging, that some chains got attacked.
Yeah.
Are there? Can you mention any chain? What was attacked?
Oh, since 2017 until today, there's been several losses with Binance Smart Chain, etc. I don't remember the names of the bridges specifically. Sometimes the developers launch the bridge to bridge, say, a blockchain and Binance Smart Chain, and people went sending money, and they accumulated $150 million, and the developers disappeared with the money.
Yeah.
It's called a rug pull, and like that, there were several cases of bridges, but I don't remember the name. Sorry,
no problem.
Specifically.
Thanks.
So regarding CBDC, what do you think is the timeline? When do we get this?
Oh, they are full steam already developing them. I am sure that now they are fighting between themselves in the design, because when you get a blockchain like Hybrid Ledger, which is Ethereum, and you suddenly tell the banks, okay, each one of you is going to be a node, and everybody's going to see your transactions of your customers, that's going to generate a lot of problems between them. That's not how they operate. And they're going to tell them, yes, but we can control people, we can know exactly everything, we can use that data to put it into artificial intelligence and create predictions per user. We can score users, their carbon footprint, we can score their social, Amos credit, and things like that. We can score all of their behavior, and banks are going to like it. But I'm sure that now they are hashing out all these details, the concept that the data and the products, they have to move all their products into the blockchain, and they have to negotiate who's going to control what. And also they have to build into the system the control mechanisms, the way to stop a transaction on the spot. As it enters, they know, oh, this is going to buy meat, boom, we need to cancel, because this person already has a very high carbon footprint or something like that. But the Nigeria, for example, already launched theirs. It wasn't very well received by the population. It was a Hyperledger platform, blockchain. China, I think, had an experiment with the CBDC that also didn't go very well. But those are just the baby steps that they're doing. I think when, your question was when?
Yeah, when, and secondly, actually, do we really want it?
No, we don't want it. The people, I mean, do we want control by our government? Do we want tyranny? Most people are going to say no, but we don't want it. And in terms of time frame, I think they're thinking 2030 to 2035 officially when you go to the World Economic Forum's website. But I think there are many central banks, there's dozens of central banks already working on this. Many are going to launch before that.
The Human Rights Foundation has developed something called the CBDC tracker, where it tracks the progress for every country on CBDCs. Some countries, citizens are a lot more amenable to it because there are pilots in China. But it's really interesting. For example, in Canada, right, they were pretty keen to develop a CBDC, but then the government kind of showed their hand early by blocking the Canadian truckers and then retroactively saying it was illegal to donate 2 weeks later to the truckers, blocking financial access to a number of Canadians that had donated to the cause when it was perfectly legal to. And so I think this kind of played into the hand of the Canadian, Bank of Canada did a study around last September, where they surveyed 90,000 Canadians, which is a pretty significant sample size, and overwhelmingly Canadians did not want to see a CBDC. So I think in cases where they're observed to see how bad it can get, it's there's kind of a bit of a warning. But I wonder sort of like, what do you feel is the best way to educate against concern, like the general populace, around the threats of CBDC? Is it things like trying, the CBDC tracker, or like, how do you think we can educate? Because like, we are immersed in this tech, we understand, right? But how does somebody just off the street?
I don't think that there's any strategy that we can do that is going to stop CBDCs. Governments have a lot of control in our lives today, even without CBDCs, even without artificial intelligence, even without these big data and all that. But they're not stoppable. What we can do is individually do like these things. I educate. I go to at my church in Oklahoma. I educate people about these things. Go one by one, and also you're going to find that people are blocked. People are not going to believe you when you say these things. No, I trust my government. I trust the CDC when it says that when you have to put the whatever vaccine that they just made 2 weeks ago. People are very trusting. I think more than 50% of the people are going to fall for these things. So education, yes, I would say I would do the approach of discipling, like Christians, that they go one by one, telling them, don't do this, please don't do this, please don't do this, and explaining these things.
Yeah. All right. Awesome. Well, thank you very much for your informative talk.
Oh.
Thanks. Hello. Our final talk of the day will be given by David Kim. He's going to talk about how Ethereum Classic can unleash and drive innovation in DeFi through its proof of work consensus mechanism. So David Kim works as a proof of work ecosystem manager at Bitmain, and he's also a contributor to the Ethereum Classic Grants DAO. He has vast experience in DeFi, quantitative trading, and financial engineering. So let's welcome David.
Okay, so good afternoon, everyone. My name is David Kim, and I'm from Seoul, South Korea, and I'm currently work at Bitmain as a proof of work ecosystem manager. And let me briefly talk about my previous experience before I joined Bitmain. So I studied math, econ, financial engineering. So I used to work in the DeFi trading space for 4 years because I found it quite relevant to my academic background. And leveraging those previous experience, I joined Bitmain, and my main job has been support the ETC ecosystem, especially with a focus on DeFi. And through which I've been working with the ETC Cooperative colleagues, including Bob Somerville. And so I'd like to thank Bob Somerville, ETC Cooperative colleagues, and LTCFoundation for inviting me to this wonderful conference, especially as a speaker, because I found most of the other speakers have in-depth expertise and experience in proof of work, which cannot be compared to mine, because I just happened to be I was just a young DeFi DJ who happened to be in the proof of work space only after I joined Bitmain. Because when I was in the DeFi trading space, I was longing for ETH merge because I believe that it would drive down the transaction cost at the time. Yeah, so again, I really thank the host of this event for this wonderful event. And my talk will be about unlocking the DeFi potential of the ETC DeFi ecosystem. And it will not be any technical narrative because all those technical details have been thoroughly discussed by Donald McIntyre, because most of my basic knowledge about ETC come from reading his articles on the ETC Cooperative. Yes, thank you, Donald McIntyre. And I will make it short and concise as possible. I know it must have been a really long day for all of you. It's going to be the last session in this stage. So, okay, let's start. My first step would be going through what is the identity of ETC and what kind of values have been pursued by the ETC. I found it quite non-trivial because still there are so many people believing with huge misconceptions about ETC. For example, still many people around me who are still in the blockchain industry, they still believe the ETC as a fork of ETH, which is totally not true. So I found it really indispensable part of the conversation for today's session. So yeah, let me start. So ETC pursues the original Ethereum vision, keeping the principle of the code is law. And its fundamentals are based upon the proof of work mechanism, which ensures robust security and network consensus. And also, ETC has a fixed supply model, which offers a more predictable monetary policy, just like Bitcoin. But how it differs from Bitcoin, it has a fifthing, not a halving, which happens every 2 years, almost 2 years. And the most recent one was in June this year. And lastly, it has smart contract capabilities, which enables creation and executions of more complex and programmable activities on chain, rather than just a mere peer-to-peer transactions. And all of those features have led ETCs to make sure that the network itself is secure, economically sound, and rich in possibilities for users and developers altogether. So it has grown as the largest proof of work smart contract blockchain platform, just like Donald emphasized. And a lot of ETC enthusiasts and community members, including myself, the way we understand ETC is like ETC equals ETH plus Bitcoin, because it resembles the ETH technological innovation, like smart contract, while preserving the philosophical tributes like network security and sound economic model. So it engendered a platform that marries the best aspects of the first and second generation blockchains, Bitcoin and Ethereum. And of course, the core of ETC is Ethereum is EVM, the Ethereum virtual machines, which engenders versatile functionality to the ecosystem. And this slide stipulates some aspects of the EVM, decentralized computing environment, which offers a global and open source environment for the devs, especially, and smart contract execution, which enables more complex and programmable activities possible on chain rather than just a mere peer-to-peer transaction. And train completeness, which solves any computational problem given enough resources. And gas system, which adopts a transaction fee mechanism to allocate resources on the network. And isolation, like it runs nodes on a completely isolated environment. And compatible standards, which allows a wide range of DApps, or decentralized applications, and interoperable projects. So it's the values that we could get from the EVM. And ETC is for sure EVM compatible. And then I'd like to move on to the history of ETC. Especially, I'd like to compare what had happened before the merge, when ETH transitioned to the POS, and what has been happening after the merge, because the merge event itself laid a strong foundation for potential mass adoption of ETC. So it's really important to go through this step. So let me quickly go through the brief ETC history. So Ethereum was launched in 2015, and a year later, the DAO raised like 150 million-ish fund, but part of it were hacked, right? If I recall correctly, like 60 million were stolen in ETH, and which led to a heated controversy over whether we should do a hard fork. And ETC stood against the hard fork, and that's how we split against. But still, yeah, ETC was the original ETH. And yeah, in 2022, the merge happened. So before the merge, most of the GPU miners were still mining ETH. So ETC, the hash rate was not stable, so it has suffered a few 51% attacks. And the current ETC builders told me that at the time, even though they were following up with the ETC, but they were reluctant to build something or start anything on ETC because the network security wasn't guaranteed at all. But now they are building something on the ETC. So, and after the merge, since ETH transitioned to the proof of stake in 2022, like many GPU miners migrated to the ETC, increasing the total network hash rate. But what's even more important about this situation was like ASIC miners, represented by current employer, Bitmain, entered this ETC mining industry, which further accelerated the growth of the hash rate overall. So those kind of events have equipped ETC network with being able to a larger network with more confirmation. But then what we should be attentive to is, so Bitmain did not just stop at just producing ASIC miners. We wanted to take more active role in this in fostering the ETC network, and we want to take more aggressive initiative to foster mature development of ETC, because we believe that ETC will be a leading platform in proof of work. I mean, like Bitmain is a company, it's a for-profit, and we see a huge market potential for ETC. So that's why it will translate into the inception of ETC Grand Style, which I'm part of, that I will be talking about shortly. So now what is happening in ETC? So basically what has been happening after the merge, especially how the ETC Grand Style got into the place. And this part will be more like a showcase how ETC Grand Style has contributed to the ETC ecosystem and how we have attempted to position ETC as a proof of work haven for future DeFi innovations. So the ETC Grand Style was established in 2022, along with the merge event. And it was based upon the partnership between ETC Cooperative and Bitmain. And Bitmain committed like 10 million of funds to support this initiative, and also ETC Cooperative committed 250K of funds to support the first round of grants. And so ETC Grand Style aims to be a community-centric initiative that supports and funds any project that can contribute to a mature development of ETC ecosystem. And ETC Cooperative represents the community-driven interest, and Bitmain represent industry-side interest. And both parties gather together in expectations of generating synergy between those two separate sectors so that we could collectively drive mature development of ETC ecosystem. So far, we have proceeded with the first round of grants along with some other additional special grants program with a focus on fostering the infrastructure, core infrastructure. And we have taken many approaches, and one of which is like active engagement with other proof of work communities. So we should acknowledge that ETC community has been relatively isolated from the rest of the proof of work community, probably because it is so decentralized that we do not have any centralized entity like Ethereum or L2Foundation that give us like directions or guide to the ecosystem. But then we recognized a strong need to further interact with the rest of the proof of work community as long as we believe in the true values of proof of work so that we can bring in more talented developers or innovation to the ecosystem. So in that regard, I really appreciate the ETC Cooperative's initiative on hosting Proof of Work Summit, through which we could get to interact with other like Proof of Work community. And so continuing on that, Bitmain has been trying to like put more resources to set up some sort of venues or conferences or like meetups through which ETC community can further facilitate those like kind of interbreeding with others. And one of which would be the World Digital Mining Summit hosted by Bitmain in June in Las Vegas, where we invited some of ETC builders to give us some sort of like a panel discussion, and along with some networking session at the venue. And then the second approach was to build the protocol parity. That means so that we could fill in those previously unoccupied, previously empty spaces before the merge, because every builder was so reluctant to build something on ETC because the hash rate was not stable enough. So we've been trying to get like existing successful project and protocols to onboard with ETC so that we could make the ETC on par with other EVM compatible chains, especially with a focus on like core infrastructure and technological offerings. And main focus has been around like supporting stablecoins, bridges, and oracles. So protocol parity, bridges, and oracle. So previously, most of the trading activities on the ETC network were severely dependent on the values of ETC because there were no stablecoin, there were no oracle that could enable like the interaction with other blockchain. So most of the trading pair that we could do on ETC was like an ETC paired with the some other ETC native governance tokens, which is not attractive to those non-ETC native traders or individual traders. So we thought that it is important to bring more tradable asset onto the network. So that's why via the first grant program, we funded the cross-chain bridge project that happened to successfully deploy bridge Bitcoin, bridge ETH, and bridge Tether on the ETC network. And also, previously, most of the trading vehicle were like just simple constant product market makers. But then we wanted to see more diversified financial product available on the network, so which requires Oracle. So we ended up funding another project that gives more possibility for collect any more complex products that might involve some sort of like a Oracle communications. And then proto-parity native stablecoins. So even though we had bridged stablecoins, we still believe that in order for the network to be more self-sustainable, we should be less dependent on protocol. So we should decrease the risk of protocol dependency risk. So that's why we try to, apart from the first rounds of grants, we supported the development of 2 decentralized ETC native stablecoin, and those are, and also apart from our grants program, recently there was an effort to deploy a fiat-backed stablecoin by ETC Swap. So now ETC has a variety of stablecoin choice, and all of them are listed on the different DEXs. That means we have tons of like arbitrage opportunity that can lead to more on-chain trading activities. So before the introduction of ETC native stablecoins, most of the variation in TVL on ETC were heavily driven by the value of the ETC. But now we see less volatility in the TVL. I know that the market has been going down for the time being, but still we see less type of volatility, and I hope to see a stable and steady upward trend in the TVL of ETC. And now also the trading markets. So ETC Swap recently introduced the concentrated liquidity against just a mere constant product market makers, which make trading more capital efficient. And also now we can short or long on ETC or something based on your own portfolio management or risk management needs with leverage. Also the prediction market, even though this project is still in its beta phase, but still, like, yeah, I look forward to its mainnet launch in the near future. So our last step is beyond the protocol parity. We should foster ETC specific innovation that we don't see in other blockchains, and I think it is still possible, and it's really likely to happen in the near future because first, ETC, unlike other like L2 token like Arbitrum or Optimism, its market cap is several billions, and it is listed on the most major like exchanges. So which makes ETC a really good choice of collateral, which will be used in many applications of DeFi products. And also, it can work as a PoW proof of work haven for truly decentralized protocols. I mean, like builders can be as much experimental as possible on ETH. They can try anything, and then take the best part of it and start building that on ETC, which is immutable, right? So they can start with a clean slate after a series of experiments on other chains. Yeah, and also a lost gas fee, which means, I mean, I was so surprised to see that ETC, even though it was a proof of work, has that low gas fee. Because before I joined Bitmain, I was in DeFi trading. I mainly used ETH and some other L2, but still, ETC is more affordable than those chains. So I think I see a bright future in ETC, and I hope that ETC Grand Style and ETC Cooperative will do a key role in driving that innovations. And thank you, and this concludes my presentation. Yeah.
Does anybody have any questions?
Yeah.
Who mines ETC mostly? Is it big corporate miners or is it individuals at home?
I'm not in a good position to disclose because
From public information.
I'll say a high net worth individual. Yeah, from my understanding, from my knowledge, there's no institutional entity mining ETC.
I would say there is no large scale. So I'm a miner myself, doing that at home. It's like ASICs and so on. Started with GPU, started even on ETH, earning like some bits of it. And yeah, so there's no public knowledge. I do have a site. I do not want to advertise. Let's keep it out of here. I will show you that.
Yeah.
Any other questions? If not, well, thank you very much. That concludes the community stage. There will be closing remarks downstairs. And let's not forget, Hive has generously bought us all dinner and drinks. That starts at 6 p.m. today at the restaurant downstairs. I can't remember the name. It's the Italian one. Awesome. Thanks, everyone.